Hello students, welcome to Time Classes. Topic of today's class is Speed Maths Workshop. I had divided this class into various segments. First of all, we learn about divisibility of a number by 2 to the power n or by 5 to the power n, which is an extension of 10 to the power n. Then in the second segment we will be learning digit sum property and solving few examples how to get the answer much faster than the normal approach. Third, multiplication by duplex or cross multiplication method, multiplication by base method. The next segment will be learning square of any number from 1 to 1000. How to write square of any number from 1 to 1000. I divide this into two parts. First from 1 to 100 and then 101 to 1000. Then square of any number ending with 5. How to write square of any number ending with 1. Further, how to find square of a number by duplex method or by a base method. Then how to find cube of a number. Further segments are how to divide a number, how to do division by two methods. Then we learn about comparison of fractions. Then how to add given 4-digit numbers, taking 2 digits at a time, or another method for addition, and then subtraction, and many more will be learning in between the examples and solving the questions. So first of all, divisibility by 2 to the power n and 5 to the power n. So if a number is ABC, we write this number as A into 10 to the power 3 plus B into 10 to the power 2 plus C into 10 to the power 1 plus D. So if we wish to divide this number by 2 to the power 1, we have to just check the unit digit, because 10 is actually 2 into 5. 100 is 2 to the power 2 into 5 to the power 2. So you have to just check for the unit digit. Suppose you want to check for 2 to the power 2, that is a number is divisible by 4. So we can write this number as AB into 10 square plus CD. Now 10 square is 2 square into 5 square. So we have to just check for the last two digits. If it is for 2 to the power 3, that is 8. So we can write this as A into 10 to the power 3 plus BCD. 10 to the power 3 is 2 to the power 3 into 5 to the power 3. So BCD, so if you want to check a number is divisible by 8, you have to check whether the last 3 digit of the number is divisible by 8 or not. In this manner, we can proceed further for 2 to the power 4 or 2 to the power n. Suppose I wish to check whether the number 6180 is divisible by 4 or not. So this is 61 into 10 to the power 2 plus 80. This is 2 to the power 2 already. So we have to check whether the last two digits of the number is divisible by 4 or not. 80 is divisible by 4. So this number is divisible by 4. In the similar manner, we can check for 5 to the power n also. So ABC, if you take a 3-digit number, this is A into 10 to the power 2 plus B into 10 to the power 1 plus C. So 10 is 5 into 2, 100 is 5 square into 2 square. So if we wish to check the number is divisible by 5, we have to just check for the last digit of the number, unit digit. If it is 0, or 5. If we need to check for 25, that is 5 to the power 2, a into 10 to the power 2 plus bc. 10 to the power 2 is 5 square into 2 square. So for 25, we need to check for the last two digits. So for 6180, if we need to check for 25, this is 61 into 10 to the power 2 plus 80. This is not divisible by 25, it's 75 goes there, so remaining is the remainder left. So this number is not perfectly divisible by 25. We have to check for the last 25. Similarly, if a number is ABCD and we need to check for 125, 125 is 5 to the power 3, so we can write this as a into 10 to the power 3 plus BCD. So in this 10 to the power 3, 5 to the power 3 is already there. So we have to just check for the last 3 digits. If the last 3 digits are divisible by 125, then we will divide this number by 125. So just looking at 125, we used to find for the check for the last 3 digits and so on. So this is an extension of 10 to the power n, 2 to the power n into 5 to the power n. So any number is a multiple of 2 to the power n. We can say any number is a multiple of 2 to the power n. Is a multiple of 2 to the power n, where last n digits are occupied by zeros or multiple of 2 to the power n. Last n digits are either occupied by zeros, are all zeros, or multiple of 2 to the power n. In a similar manner, we can say any number is a multiple of 5 to the power n when either last n places are occupied by zeros or multiple of 5 to the power n. So we have to check for whether 2 to the power n or 5 to the power n. We have to check for the last n digits are occupied by either zeros or multiple of 2 to the power n. Then the number is divisible by 2 to the power n. Or they are zeros or multiple of 5 to the power n. Then the number is multiple of 5 to the power n. Now by 9, if we wish to find a number by 9, so it's ABCD is a number. We can say this is A into 1000 plus B into 100 plus C into 10 plus D. So this can be written as A into 999 plus 1 plus B into 99 plus 1 plus C into 9 plus 1 plus D. So 999 and 999 and so on are all divisible by 9. So we have to just check for sum of the digits A plus B plus C plus D is divisible by 9. If sum of the digit is divisible by 9, the number is divisible by 9. This is multiplication divisibility by 9. So we have to just find the sum of the digits. If it is 0 or multiple of 9, the number is divisible by 9. Now by 11, in a similar manner, we can write this as, suppose I take a number as ABC This is A into 10 to the power 2 plus B into 10 plus C. So it's A into 99 plus 1 plus B into 11 minus 1 plus C. So this is A minus B plus C is divisible by 0 or multiple of 11, then the number is divisible by 11. That is, we wish to say sum of the odd digits minus sum of even digits is either 0 or multiple of 11. If a number is ABCD, we can write in the format basic decimal notation: A into 10 to the power 3 plus B into 10 to the power 2 plus C into 10 plus D. This 10 can be written as 11 minus 1 plus B into 11 minus 1 whole square plus C into 11 minus 1 plus D. So whenever power is odd, we will be getting a minus sign at the end. All other terms are divisible by 11. And power is even, we get a plus sign, plus 1, which multiplied by the number digit which is outside the bracket. So it is minus A plus B minus C plus D. That is sum of odd digits minus sum of even digits should be either 0 or multiple of 11. Then the number is divisible by 11. Let's take first question. It says a number is n is A44732987. Find the most significant digit, that is A. Now since it's the most significant digit, so that the number is multiple of 11. Since n is a number given, A is the most significant digit, you have to find the value of A so that this number is multiple of 11. So we just apply the rule which we learned just now. We'll add sum of the odd digits: 7 plus 9, 16 plus 3, 19 plus 4, 23 plus A. That is, sum of the odd digit is 23 plus A minus sum of the even digits: 8 plus 2, 10, 10 plus 7, 17, 17 plus 4, 21. So this 23 plus A minus 21 should be either 0 or multiple of 11 or 22. So that is, A plus 2 is either 0 or A plus 2 is either 0 or 11 or 22. So if we equate this two part, this is not possible. A plus 2 cannot be equal to 0. If we equate these two part, A plus 2 is equal to 11. So A is equal to 9, which is possible. A is 9. A plus 2 is equal to 22. A gives 20, which is not possible as A is a single digit. And A cannot be 0 as it is the most significant digit. So we got only a unique value of A as 9. A equal to 9. So most significant digit, so that the number is multiple of 11, is 9, because it's 9 plus 2 becomes 11. So the number is divisible by 11. All other cases are ruled out. A plus 2 cannot be equal to 0, otherwise A becomes negative. A plus 2 cannot be equal to 22, otherwise A becomes 20, which is a 2-digit number, not possible for the most significant value. So only possible choice is A plus 2 equal to 11, that is A is equal to 9. Yes? Question second. Find the number of possible pairs of A and B, so that the given number is a multiple of 225. Now 225 is 25 into 9. 25 into 10 is 250. This is 25 into 9. So for a number to be divisible by 25, last two digits should be divisible by 25. That is B5. It can be 25 or it can be 75. So B can have two values. Either B is 2 or B is 7. So the number is divisible by 25 is maintained, is for sure. Now for 9, it has to be sum of the digits to be divisible by 9. Number is 6, 7, 8, 9, 4, 8, B, 5. 5 plus B, we do not know, B is either 2 or 7. 5 plus 8 is 13, plus 4 17, plus 9 26, plus 7, 26 plus 7 is 33, plus 6 is 39. This gives us 39 plus 8. 36 is divisible by 9, so it is 3 plus A plus B also should be divisible by 9. 3 plus A plus B should be divisible by 9. Or we can straight away strike out those numbers whose sums add up to 9. For example, 9, 5 and 4 is 9. We can rule them out. 8 plus 7. 8 plus 7 we take 1, it's 6 is left. 6 plus 6, 12. 9 goes out. It's 3 plus A plus B should be divisible by 9. Now we have to consider two cases when B is either 2. So it becomes 3 plus A plus 2. That is 5 plus A should be divisible by 9. So A is 4 in this case, as A has to be a single digit number. It cannot be 18. Otherwise A value of A becomes 13, which is a 2-digit number, not possible. Or if we take B as 7, so 3 plus 7 plus A, that is 10 plus A is divisible by 9. So we can take value of A as 8, because 10 plus A can be 18 when A is 8. Only possible value of it. So one pair for A and B we have when A is 4, B is 2. Other is A is 8, B as 7. So we had how many number of possible pairs of A and B? 2 possible pairs of A, so that the number is multiple of 225, which is 25 into 9. So we satisfy these two properties individually. Yes? Question third. Different 6-digit numbers are formed with the help of the digits 2, 3, 5, 7, 4, 0. 6 digits are given without repetition of digits. First of all, if we wish to find how many such numbers are possible, different 6-digit numbers, repetition not allowed. First place 0 cannot occupy, otherwise this will become a 5-digit number. So to fill this place we had 5 choices. Then for the remaining we had 5, 0 can come here, into 4, into 3, into 2, into 1. That is 5 into 5 factorial. Factorial 5 is 120. So 5 into 120 is 600 numbers are possible, which can be found with the help of the digits 2, 3, 5, 7, 4, 0 without repetition of digits. But question is saying find the number of 6-digit numbers, 6-digit perfect square numbers that can be found. So we have to find how many perfect squares are there from this 600 numbers which can be formed with the help of these digits. Now for a number to be a perfect square, when we do a prime factorization, we write this as a to the power p, b to the power q, c to the power r, and so on. Here ABC belongs to prime numbers, and PQR belongs to natural numbers. This is prime factorization, a unique way to represent any number. One way, only one way we can write in a prime factorization. So for a number to be perfect square, these PQR should be even numbers. Power should be even. So that when we take a square root, we do not get an irrational power. We get a rational number. So we need to find how many 6-digit perfect square numbers that can be formed from these numbers. If we carefully observe the numbers, all the digits will be used up. 2 plus 3 plus 5 plus 7 plus 4 plus 0. 2 plus 3 is 5, 5 plus 5 is 10, 10 plus 7 is 17, 4 21 plus 0. Sum of the digits is 21. So the number, whatever number you form, these all 600 numbers are surely divisible by 3. For sure. But 21 is not divisible by 9. So number is not divisible by 9, but number is divisible by 3 for sure. All of the 600 numbers which we can form in this manner are divisible by 3. That is, they have 3 to the power 1 in the prime factorization, but they do not divisible by 9. So this number, any of these number can never be a perfect square. So there is no such perfect square number exists. Find the number of 6-digit perfect square number that can be formed. It's none. No such number is possible. So none such number is possible in this case. So which property use? The number is not divisible by 9, despite the number is divisible by 3. Because sum of the digit is divisible by 3. That is 21 is divisible by 3. But 21 is not divisible by 9. So we can safely say that we are not able to get any number from these 6-digit number which is a perfect square. So none such number is possible. Question 4th. Now this is a 10-digit number. ABC are distinct non-zero digits. 10-digit number ABC are distinct non-zero digits. Find the number of possible triplets of A, B, C such that this number is a perfect cube number. Perfect cube number, when we do prime factorization, we got all the powers of prime number as multiple of 3. It's 3k1, b 3k2 and so on. Then it's a perfect cube. AB are prime numbers and powers is multiple of 3. Once again he says whatever condition is given, 6, 7, ABC, 5, 2, 3, 5, 6. It's a 10-digit number. ABC are distinct. Condition is given as ABC are distinct and non-zero. Distinct and non-zero. So distinct digits, non-zero digits. But condition is possible triplets of ABC such that n is a perfect cube number. Now this is an even number, divisible by 2 for sure, divisible by 4, as last 2 digits are divisible by 4. But this number is not divisible by 8. Not divisible by 8. Last 3 digits are 356. That is 320 plus 36. That is 32 plus 4. This is divisible by 8. This is divisible by 8. But we are getting a remainder. So this number is not divisible by 8. But this number is divisible by 4. So when we do prime factorization, we will be getting 2 to the power 2, but we will not getting 2 to the power 3. So power of 2 is not a multiple of 3. So we will not get any perfect cube. So how many such triplets are possible? No such triplets are possible. Once again, no such triplets are possible. Why? Because the number is divisible by 4 but the number is not divisible by 8. So we had in prime factorization 2 to the power 2. So when we take a perfect cube, we will not getting a natural number in this case. So no such perfect cube number is possible. Whatever the values, this ABC can be assigned. Yet given extra condition that ABC are distinct and non-zero digits, but this number is not divisible by 8. So we will say no such perfect cube number will exist. So no such perfect cube number is there. Sure. Then moving to another segment that's called digit sum. Digit sum, suppose the number is 112, it's 1 plus 2, digit sum is 3. 3, 4, 1, digit sum is 3 plus 4 plus 1, that is 8. 1, 5, digit sum is 6. Sum of the digits, single digit sum is 6. Indirectly we can also say digit sum is basically a remainder when a number is divided by 9. It's basically a remainder when a number is divided by 9, or is a sum of the digits, we say single digit sum. Suppose we write this as 963. This is 9 plus 6 plus 3. 9, 6 plus 3 is 9, 9 plus 9 is 18. 18 is 1 plus 8, that is digit sum is 9. Now 9 does not play any role in the digit sum. For example, I had taken a number as 52. I had taken number as 52. Digit sum is 5 plus 2, that is 7. If I wish to find digit sum of 952, so this is 9 plus 5 plus 2, 9 plus 5 plus 2, 5 plus 2 is 7 plus 9, 16, which is again 1 plus 6, that is 7. 9, 5, 2, 8, 1. I need to find digit sum is 9 plus 5 plus 2 plus 8 plus 1. 9 plus 5 is 14, 16. 16 plus 8 is 24 plus 1, 25. 25 is 2 plus 5, that is 7. So digit sum, what we used to learn from this part? Whatever mathematical operation we apply, whether addition, subtraction or multiplication, digit sum remains the same. So we'll be using this property to find our answer. Now let's learn this by taking certain examples, certain questions. Now let's do this question by digit sum approach. Its sum of the digits is 5, 1 plus 1 plus 1, 3 plus 0 plus 2 is 5. Then it's into 2 plus 1 is 3, 1 plus 1 is 2. 5 3 the 15 into 2 30, that is 3 plus 0, digit sum is 3. We have to just check which choice this gives us as digit sum as 3. So digit sum of first number is 1 1 1, 3 plus 0 plus 2 is 5, 1 plus 2 is 3, 1 plus 1 is 2. So 5 into 3 is 15. Into 2 is 30, 30 is 3 plus 0, so we get digit sum is 3. Now 4 plus 6 is 10, 14, 19, 25, 29, 130, 27 goes out, digit sum is 3. 4 plus 6, 10, 14, 19, 22, 28, 29, digit sum is 2. 6 plus 4, 10 plus 4, 14 plus 5, 19, 3, 22, 28, 29, 27 goes out, digit sum is 2. 4 plus 6, 10 plus 4, 14, 14, 5, 19, 25, 27, digit sum is 0. 4 plus 6, 10, 14, 19, 25, 29, 34. So digit sum is 7, 34. 27 plus 7 is 34. So we had only one choice whose digit sum is same. Digit sum doesn't changes whether you multiply, add or subtract. So answer is choice A. Now let's see one more approach in this case. We had last digit same, unit digit same in the three part, but last two digits are different in all the four choices. So let's apply last two digits. It's 11 into 21 into 11. 11 into 11 is 121, that is last two digits is 21 multiplied by 21, which is 441. So last two digit or our choice has to be 41. We had only one choice left. So we can do this question in this particular manner also, either by using the digit sum approach or by using the last two digit. But last digit won't work out in this case as we had one same in this part. Yes? Now if you look at this question, we had digits as 8467, 8476. So digit sum won't work out in this case. So we go for, but last digit are different. Last digit or last two digit we can say. We can take last two digits as last digit is same in these two cases. But let's check what we get. It's 3 minus y plus 1 is equal to 7. So we get y as 4 minus 7. That is, we take a borrow from this side. It's 14 minus 7. That is 7. So last digit of the answer has to be 7. So we straight away had only one choice left, 8467. We can take last two digit also. It's 93. We had plus 51 minus 77 is equal to 1. So it's 495, 144 minus 77. So we have to subtract 144 minus 77. So it's 7. It's 6. 67 as the last two digit. So we had only a single choice which have 67 as the last two digit. So can be done in this manner also. Yes? When we take the unit digit, we get digit as 7. So these two choices are straight away ruled out. So we can mark from our last digit also. We can mark from last two digit also. Now let's come to another example. Its last two digit are different. So let's apply the last two digit part. First, we apply its 68 plus 58 minus 96 minus x is equal to 21 plus 62. We have to just simplify this part. So we can say 62, 68, 6 is left. We have 21, then 6 plus 58 is 58, 64 minus 96 minus 21 is equal to x. So it's 117, 64 minus, that comes out to be, if we subtract 64, it comes out to be minus, we subtract 64 from this, we get 3 and 5, minus 53 we get. So we have to borrow, we have to take 100, so it should be 1 minus 53 from 100 is 47 as the last two digit. So we get our answer as 1247. We can simply straight away add, it's 68 plus 58, then we have to subtract 96, then we have to subtract 21 and 62. This gives the last digits. So it's 6, 126, 6, 7, 8, 9, 179. So we required a borrow. Because if we subtract 126 minus 179, we are getting minus 53. So we required a borrow. So 100 minus 53 is 47 as the last two digits. We can get last two digit as 47 in one choice. This is one way to solve this part. Another method is apply digit sum. So whenever the two digits add up to 9, we just leave that part. 6 and 3 is 9. 8 and 4 is 12. So digit sum of the first part is 3. 8 and 1 is 9. 2 plus 5 is 7. So we have 3 plus 7. This is 9. 6 and 5 is 11. So 9 goes out. Only 2 is left. Minus x is equal to 43729. We had 1 as the digit sum. 62819. We had 2 as the digit sum left. So this is 10 minus 2 is 8 minus 3. Digit sum should be 5 for the answer. Just check which answer gives us 5. 6 and 6, 12 and 1, 13. We get digit sum as 4. 7, 8, 9. Again 4. 7 and 2, 9. We have digit sum as 5. 8 and 1, 9. 4 and 3. Digit sum as 7. So only one choice gives a digit sum as 5. So answer is C choice. So we can apply last two digit also. We can apply digit sum property also. Yes? In this we can, all the unit digit are also different. We can apply last digit also in this case. That will be much easier to find. Last digit also we can apply. Yes? No. It's 9999. Unit digit is same. 19, 09, 09 and 19. So last two digit won't work in this case. Let's see. Let's try this part also. Why it won't work? 21 plus 86 minus 98 is equal to x should be the last two digits. So this is 107 minus 98. Last two digits are 09. So this option ruled out. This option ruled out. We had two options left. Now let's try for digit sum approach. It's 8 and 1, 9, 5, 3, 8, 2, 10. 1 is the digit sum. 9, 6 and 3, 9, 8 and 6. So 9 goes out, we are left with 5. 5 plus 1 is 6 is equal to x. 9, 7 and 3, 10, 1, 8 and 9, it's 0. So digit sum of the answer has to be 6. Because it's 5 plus 1, we get digit sum as 6. So we are looking for 6 in the options. So 9, 9, 6, 7, 8. First option ruled out. Then it's straight away 6. 9, 9, 6 and 2, 8. 9, 9, 8 and 1, 9. We get 6. So in this case, we are getting 6 in this case also. It's 9, 9 goes out, 8 and 1, 9, 6. But we know last two digits are 0, 9. So we will mark the answer as choice B as the answer because these two options are already ruled out. So here we apply a mix because digit sums in these digits it's also 6 and in this case 9, 9, 8 and 1, 9. This is also 6. So we are getting 6 in this case also. So that's why we use both together to eliminate the choices. Clear? So answer is choice B as the answer. First method gives us eliminate two choices, we are left with two choices, and second method we zero down to one of the choices. Now let's try this part. Now before we move, just see 6984, 6984 same digits. So digit sum won't work in this part. 6984 and 6894 same digit. This sum will come out same. So let's try. And unit digit is same across. Last two digit is 84, 84, 94 and 54. We had last two digit 84, 84, 94 and 54. Last two digit also same in these two parts. Let's try for the last two digit. it's possible that first two options are not among the required one, then we can straight away mark. It's 60 plus 56 minus 50 plus 28. So 60 minus 50 is 10. 10 plus 56 is 66. 66 plus 20 is 86. 86 plus 8 is 94. We had only a single option. So we get choice as choice C as the answer. It's not necessary every time we should add. So we just find the last two digit and straight away get the answer by using the last two digit in this case. So these two options 6894 and 6984 will have the same digit sum. So by digit sum we will not get the correct approach. So we try the last two digit in this case. Now let's apply to this part. 3 and 3 6 and 8 14. So digit sum is 5. 9 we leave 9 7. 8 and 1 9. 5 and 3 is 8. 7 into 5 is 35 minus 8. Digit sum is 8 minus 8, that is 0. So the answer should give us digit sum as 0. So it's 9, 5, 6, 7, 8, 9. Digit sum of the digit is 0. It's 9, 5, 6, 7, 8, 9, 10. Digit sum is 1. 9, 9, 5, 7 and 1, 8. 9 goes out, 5, 6, 7, 8, 9. Digit sum is 2. So we had only one choice whose answer digit sum is 0. That is choice A. So we straight away can mark the answer as 3095. Choice A as the answer. Yes. Let's try another type. It says m is equal to 0.2 plus 0.2 square plus 0.02 square, and n is 0.3 plus 0.33 square plus 0.333 square. We have to find the value of m plus n. Let's try digit sum approach. Now, we ignore the decimal part. Digit sum of the first part in m is 2. Then is 2 square, that is 4. And it's 2 square, again 4. 4 plus 4, 8 plus 2, 10. So digit sum of m is 1. For n, it's 3. Now 3 plus 3 is 6. 6 square is 36. Which is digit sum is 0. 3 plus 3 plus 3 is 9. 9 square is, this is 9 square. So digit sum is 3 plus 6 square is 36 divisible by 9, or 36, 3 plus 6 is 9. So 9 doesn't play any role in the digit sum. Digit sum is 9. So we leave these two parts. It's also 9. This is also 9. So 9 plus 9, 18 plus 3, 21. That is 2 plus 1, which is 3. We can directly calculate this also, because 9 doesn't play any role in digit sum. 6 square is 36. So 36 is 3 plus 6, 9. 9 square is 81. 1 plus 8 is 9. 9 plus 9 is 18. 1 plus 8 is 9. 9 plus 3 is 12. 2 plus 1 is 3. Or 9 plus 9, 18 plus 3, 21. 21, 2 plus 1, 3. So we are looking for an option choice which gives us m plus n. So digit sum of our answer choice has to be 1 plus 3. That is 4. Just look for the digit sum. It's 9. It's 9. 5, 3, 8, 1, 9. Digit sum is 3. First choice gives us 3. We require 4. Now 9, 9 goes out. 8 and 1, 9 goes out. 6 and 2, it's 8. Then we come to third part. It's a 9, 8 and 1, 9. 7 and 6. 7 and 2, 9. So we are left with 4. Decimal doesn't play any role in the digit sum. So it's 9, 9, 5, 3, 8, 2, 10, 1, 6 and 1. We get digit sum as 7. So only one choice as the answer. Answer is choice C as the answer. its digit sum matches with m plus n. So what we are calculating, we are just solving this by using a digit sum approach. If you square a number or add a number or subtract a number, and you get a resultant sum, so digit sum of all individual part is equal to the digit sum of the resultant answer, that is m plus n in this case. Clear? Now let's come to this part. When a number is increased by 22%, a number is increased by 22% and added to 5827.12, it becomes this value. Take this value. If the number is, we assume any number is y, when we increase it by 22%, so multiplying factor is 1.22. 100 plus 22 is 122. We shift the decimal by 2 places, 1.22. And we add this and is added to this number 5827.12. We get the resultant as 1210765. 1210765. 1210765. Now we have to subtract this part from the right hand side and then divide the resultant by 1.22 to get the answer, which is one among the 4 choices available. So let's apply the digit sum approach. Y into 2 plus 2, 4 plus 1, 5, ignoring the decimal part, plus 8 and 1 is 9, 7 and 2 is 9, 5 plus 2 is 7, is equal to, we say 6, it's 7 and 2 9, 1 plus 1 2, 2 plus 6 8, 8 plus 1 is 9, so 4 is left. So we add 4 on the right side. So we say 5y is equal to 4 minus 7, that is minus 3. Minus 3 means 9 minus 3 is 6. So y is 6 by 5. Whenever we have number in the denominator, 5 in the denominator, we multiply both by 2. So that in the denominator we get 10, whose digit sum is 1. In the numerator we got 12. So digit sum of this is 3. Digit sum of this is 1. So we have to look for a choice whose digit sum is 3. Just see the choices. Choices 5, 4, 9. 9 goes out. 8 and 1, 9, 6 and 6, 12. So 3 is the digit sum. So 5 and 4, 9. 9 goes out. 8 and 4, 12. 3. 3 plus 7, 10. 1 is the digit sum. So not our answer. Ruled out. First can be a possibility. We are checking for others. 9, 9. Now 8 and 1, 9. 6 is left. 6 and 6, 12. 3 is left. 3 and 5 is 8. So we get digit sum as 8. This is also ruled out. 9. So 4 and 3, 7. 7 plus 2, 9. 6 left out. 6, 4, 10. 1 is left out. 1 plus 3 is 4. Digit sum is 4. So for sure we can say our answer is the first choice. Straight away we can get the answer by using the digit sum approach. This is one of the methods. Normal method we know, we subtract this part 5827.12 from the right hand side, then whatever value we get, we divide this by 1.22 and get the value of y. One way. Other way is to just find the digit sum and apply. So whenever we have some value in the denominator, we try to multiply it by a number so that digit sum of the denominator becomes 1. Yes? Let's take another part. It says find the simple interest on principal is 381500 rupees in 5 years at the rate of 8.375%. So simple interest is principal into time into rate by 100. Now we know the value of the principal 381500. Duration is 5 years and rate is 8.375 divided by 100. Now one thing is for sure, simple interest we know is principal into time into rate by 100. Now this, we can ignore this 0 and decimal. So let's apply the digit sum property. We have to find this value. This is simple interest on principal 381500 for 5 years at 8.375 rate of interest per annum. So 8 and 1 9, 5 plus 3 is 8 into 5. 8 1 9, 2 is left, 2 plus 7 is 9, so we get 5. 8 into 5 is 40, so digit sum is 4. 4 into 5 is 20, digit sum is 2. Or we can say 5 into 5 is 25, 25 into 8 is 200, so digit sum is 2. Let's find the option which gives us digit sum as 2. So 9 we ignore out, it's 5 and 5 10, so 1 is left, 1 1 2 and 7 goes out, it's 5 2 7 1 8 and 1 9, so 2 is the digit sum. This can be our answer choice. But we have to check for other choices also. So 5 1 6 3 9, 6 4 10, 1 is left, 1 and 8 9, 7 and 3 10, 1 is left, 1 plus 5 is 6. Now 6 plus 1 7 is 7 14, so 5 is left, 5 plus 5 is 10, 1 is left, 1 plus 2 is 3, 3 and 6 9, nothing is left, 5 plus 2 is 7, digit sum is 7. Then 5 and 4 is 9, 6 1 7 1 8 2 10, 1 is left, 1 plus 2 and 2, 4 and 1 5 and 5 10, so we get digit sum as 1. So we can say our answer is first choice without actually solving these values. So we can apply this approach of digit sum to these type of questions. Wherever calculations are, or whatever mathematical operations are involved, digit sum of the answer will not change. It will remain what are the digit sum and whatever the mathematical operations are being done, multiplication, addition or subtraction. And this decimal, zeros, and divisible by 100 or decimals or percentage, we just ignore them to find the digit sum. Yes? Now let's take another question. It says find x is 1 by 8 plus 1 upon 0.8 plus 1 upon 0.08 1 upon 0.008 up to 8 terms. So digit sum of this part is 1 by 8. First term is 1 by 8. Whenever 8 is there in the denominator, we multiply it by 8 in the numerator as well as denominator. So denominator becomes 64. Numerator is 8. 6 plus 4 is 10. Digit sum is 1. Digit sum is 8. So digit sum of every part, we know the decimal part, digit sum of every part is 8. Once again 1 upon 8 was there. We multiply this part by 8 in the denominator as well as in the numerator. So 8 into 8 becomes 64. 63 is divisible by 9. So 64 is 6 plus 4, 10. That is 10 is 1. Digit sum of the denominator is 1. So we had digit sum of each part as 8. And there are 8 such terms. So we can say digit sum of our answer is 8 into 8. That is 64. 6 plus 4, 10 is 1. So we have to look for a choice which gives 1 as the digit sum. So just finding the digit sum. 5 is 5 times 25, 3 28, 1 29, 3 32, plus 7 39, plus 5 44. So we have digit sum of the first part as 8. 6 is 5 times, so 30, 4 34, plus 1 35, 41, 43, it's 48. We have digit sum as 3. 8 5 times 40, 43, 144, 44 plus 8, 52, 7, 59, 5, 64, 59, 5, 64. Then 6 goes out, digit sum is 1. Can be our answer choice. 4 5 times 20, 222, 123, 124, 226, plus 5, 31. Digit sum is, we had 4. So 4 5 times is 20. 22, 23, 24, 26 plus 5, 31. Digit sum is 4. So only one choice is matched with our answer is choice C as the answer. Yes? Clear? Now, let's solve this part. 4, we are applying the digit sum part, digit sum approach. 4 and 4, 8 plus 3 is 11. So 1 plus 1 is 2. Into 4 and 5, 9, we are left with 6 minus 9 goes out, 7 and 2 is 9, so we are left with 8 plus we had this 2, we can ignore the percentage part, into 5, 5, 5, 15, we had 6. This we have to find. So 6 into 2 is 12. So digit sum is 3 minus 8. 6 into 2 is 12 plus 3 is equal to x. So 3 plus 3 is 6 minus 8. X is minus 2. So digit sum we are looking for 7 as the digit sum. Let's see which choice gives us 7 as the digit sum. 8 and 1 9. 4 3 7 2 9. Digit sum is 1 in the first case. 9 goes out. 7 and 2 9 goes out. 3 and 3 6 and 1 7. This can be our answer. 6 and 3 9. 7 and 2 9. Digit sum is 5. 9. 8 and 1 9. 3 and 3 6 and 2 8 as the digit sum. So our answer is choice B as the answer. I hope this part clear to everyone. Yes. So what we had done, we had applied the digit sum approach. We ignored the percentage part, we ignored the decimal part. We have to keep whether it's multiplication, so we have to multiply the digit sum. If it's subtraction, we need to subtract the two part. Clear? Now, this question says, Giri buy 14 saris at an average cost of rupees 835. 14 saris at an average cost of rupees 835. If we buy 11 saris more at an average cost of rupees 645, then what will be the average cost of all the saris that he buys together? So it's a simple average question. So Giri buys 14 saris at an average cost of rupees 835. So this is the overall cost of these 14 saris, and 11 saris more at an average cost of 645. So this is the total cost which Giri had paid for how many saris? 14 in the first part and 11 in the second part, that is 25 saris. So one way is to solve this expression and get the answer. Other way is apply the digit sum approach. Digit sum approach. So 4 plus 1 is 5. 8, 1, 9. 8, 3 is 11. 9 goes out. 2 plus 5 is 7. 1 plus 1 is 2. 5 plus 4 is 9. So 6 is left. Divide by, we had 25. 14 plus 11 is 25. So 7 digit sum in the denominator. Yes. Now 5 into 7 is 35. Digit sum is 8. 6 and 2 is 12. Digit sum is 3. Denominator we had 7. So whenever we had 7 in the denominator, we multiplied by 4 in the numerator and denominator. 7 into 4 becomes 28. So digit sum of the denominator becomes 1. 11 into 4 is 44. 11 into 4 is 44. So digit sum is 8. So we are looking for an option whose digit sum is 8 as their answer. Whenever 7 is there in the denominator, we multiply it by 4 in the numerator or denominator. To make denominator, our number of digit sum is 1. If there is 4, so we multiply it by 7. Yes? Now, just see the options, choices. 5 and 4 is 9. 8 as the digit sum can be our answer choice. 4 and 3 7 and 4 11, 3 14 and 7 21. Digit sum is 3. 6 and 4 10. So we are left with 1. 1 plus 5 is 6. 6 and 2 8. 8 and 1 9. We are left with 6. 7 7 14 plus 6 20 plus 8 28. Digit sum is 1. So we had only one choice as whose digit sum is 8. Choice A as the answer. Yes? Now, it says from his monthly income, A spent 24% on household expenses. A spent 24% on household expenses of his monthly income, 16% on entertainment, and 28% on education. So indirectly, 24 plus 16 is 40. 68% is spent. So he is left with 32%. So his income is P. So he spent 68%. So he left with 32% of his income, 0.32. Out of all the remaining, he donates 72% money. This is the remaining amount, 32% of his income. He donates 72%. So he is left with 28% of the remaining amount. And this amount is given as 2403.52. Question says, his income is P. He spent 24% of his income on household expenses, 16% on entertainment, 28% on education. So 24 plus 16 is 40 plus 28 is 68%. So he is left with 32% of his income. So P into 0.32 is the income left part. This part is the income left. And out of the remaining he donates 72%. So he is left with 28%. So 0.28, this is the amount he was left with. We have to find his monthly income, that is P. One method is to solve this expression. Divide right hand side by 0.28 and 0.32 and get the required value. Another way is to apply the digit sum approach. This is P into 3 plus 2 is 5. 2 plus 8 is 10. So we got 1 as a digit sum. 5 and 4 is 9. We know the decimal part. 2 plus 3 is 5. Plus 2 is 7 on the right hand side. So P is equal to 7 by 5. Whenever we got 5 in the denominator, we multiply it by 2. So the denominator it becomes 10, whose digit sum is 1. And in the numerator we had 14, 1 plus 4, that is 5. We are looking for a digit sum as 5 in the answer choices. Let's see which answer choice fits in for this. 7 and 2, 9, 5 and 4, 9, digit sum is 2. 5 to 7 to 9, 8 and 1, 9, 8 and 6 is 14, where digit sum is 5. This can be our answer choice. 5 and 2, 7 and 2, 9, 8 and 6 is 14. So 9 goes out, 5 is left. Then we had 5 to 7 to 9, 6 and 5 is 11, 2 as the digit sum. Then 9 goes out, 5 to 7 to 9, 3 as the digit sum. So we had only one choice, which is given as choice B as the answer. Yes? Now, whenever we have in the denominator a number and we are finding using our digit sum approach. So whenever its denominator is 1, digit sum is of the denominator is 1. Suppose we had in the denominator it's a upon 2. So we multiplied by 5, numerator and denominator, so the denominator becomes 10, whose digit sum is 1. If we had 5 in the denominator, we multiplied by 2, numerator and denominator, so that in the denominator it becomes 10, so digit sum of 10 is 1. If we had 7 in the denominator, we multiplied by 4, numerator and denominator, so that it becomes, numerator is multiplied by 4, denominator becomes 28, whose digit sum is 10, that is 1. If we had 4 in the denominator, we multiplied by 7 in the numerator and denominator, so that numerator is multiplied by 7, but denominator becomes 28, whose digit sum is 10, that is 1. Yes? I hope this part is clear. Whenever we have 8 in the denominator, we multiply numerator and denominator by 8. So 8 into 8 becomes 64, whose digit sum is 6 plus 4, 10, that is 1. So if we summarize numerator and denominator, 1, we want to make digit sum of the denominator as 1. If it is 2 oblique 5, so we multiplied by numerator and denominator by the other number. If it's 2 in the denominator, we multiplied by 5 in the numerator and denominator. So whenever we are talking about a number whose part is a upon b, if denominator is 1, its digit sum is 1. If it is 5, we multiplied by 2. If it is 2, we multiplied by 5. We can say if denominator is 4, so we multiplied by 7. If denominator is 7, we multiplied by 4. So that digit sum becomes 1. We multiply both numerator and denominator. And if it's 8 in the denominator, we multiplied by 8. So 8 into 8 becomes 64, whose digit sum is 1. Yes. So you have to slightly be careful when there is a part in the denominator also, by using the digit sum approach. Another question, it says the population of a town is increased by 7%. The population of a town is increased by 7% at the end of first year, decreased by 6% at the end of the second year, and again increased by 3% at the end of the third year. If the population at the end of the third year was given as 566, 522, 3819, then we have to find the population at the beginning of the first year. Let's assume the initial population is P. It increased by 7%, so multiplying factor is 1.07 at the end of the first year. This is the population at the end of the first year. Decreased by 6% at the end of the second year, so this is 0.94. And again increased by 3% at the end of the third year. So 1.03 is the multiplying factor. This should be equal to final population 566, 522, 3819. 566, 522, 3819. You have to find T. One method is the value at the right hand side is divided by 1.07, 0.94 and 1.03, and then we get the required answer. Other approaches apply digit sum approach. This is P into, we are applying the digit sum approach. So ignore the decimal part. 1 plus 7 is 8. So ignore the 9, it's 4. 1 plus 3 is 4. Now digit sum on the right hand side we need to check. It's 9, we leave this. 8 and 1 is 9. 3 plus 2, 5 plus 2, 7. 7 and 5 is 12. So 3 is left. 3 plus 6 is 9. 6 plus 5 is 11. So we get digit sum as 2. Now 8 into 4 is 32. Digit sum is 5. 3 plus 2 is 5. And 5 into 4 is 20. And the digit sum is 2. So 2p is equal to 2. We have to check for digit sum as 1. Let's see. We have done 8 into 4 is 32. 8 into 4 is 32. Digit sum is 5. So this is sum 5 multiplied by 4 becomes 20. Digit sum is 2. So left hand side is 2p, right hand side is 2. So p is 1. Now let's see the answer choices. Which answer choice do we have? So 5 to 7. 7 and 6 13 plus 2 15 plus 5 20. Digit sum is 2. 5 and 4 9. 6 into 8 plus 1 9. So we are left with 4. 5 5 5 5 5 25. So it's 18. We had 25. Digit sum is 7. So it's 5 plus 4 9. We leave this part. 6 plus 8 14 plus 5 19. Digit sum is 1. Or 8 plus 5 13 plus 6 19. 18 goes out, digit sum is 1. So answer choice is choice D as the answer. Yes? Now let's solve this part. It says 11122 divided by 134. So let's see the digit sum part. It says 2 plus 2 is 4, 5, 6, 7. So we had 7 in the numerator. 4, 3, 7 plus 1, 8 in the denominator. Plus, we ignore the percentage. 6 plus 2 is 8. We had 8 in this part. 7, 4, 11 plus 1, 12. So 3. 8 into 3 is 24. So this part digit sum is 6. And whenever we have 8 in the denominator, we multiply it by 8 in the numerator and denominator. So that becomes 64, whose digit sum is 6 plus 4, that is 10, 1. So numerator is 8, 7. 8 into 7 is 56. 6 plus 5 is 11. 9 goes out, 2 left. So we are looking for an answer choice whose digit sum is 8. We are looking for an answer choice whose digit sum is 8. So 5 and 4, 9. 6 into 8. This can be our answer. 5 and 6, 11, 3, 14 to 16. So we have digit sum is 7. 6 and 6, 12, 14 and 16. Again we have digit sum as 7. 8 plus 2, 10 plus 4, 14, 6, 20. Digit sum is 2. So we had only a single choice as choice A as the answer. Yes? Yes? So answer is choice A. Let's try this part. Square root of 1 plus 19 to 91 into 92 into 93. Now, traditional normal method is multiply these 4 values, add 1, take square root and get the answer. Other method, digit sum of 90 is 0. So whatever value we get from this part, digit sum is 0 plus 1. So we have to just look for the digit sum as 1 in the choices. So 8 and 3, 11. So 2 is left, 2 plus 7 is 9. We got 1 as the digit sum. 7 and 2 is 9. 8 plus 1 is 9. Digit sum is 0. So this is not the answer choice. 4, 3, 7, 1, 8 and 8, 16. Digit sum is 7. Not the answer choice. 8 and 2, 8 and 1 is 9. 3 and 2, 5. So only one choice is left. That is 8371 as the answer. Yes? Find the compound interest. What we have to find? Compound interest. Compound interest is P into 1 plus R upon 100 to the whole power n minus 1. If rate percent is R percent per annum and n is the number of years and P is the principal. It says find the compound interest on 11280, this is the rupees, for 1.5 years at 38% per annum. The interest being payable half yearly. Can you say 38% per annum divided by 2? So half yearly rate of interest is 19% per half yearly. And in 1.5 years we had 3 half yearlies. So if we apply this formula, we will say 11280 into rate percent is 19%. So 1 plus 19 upon 100 to the whole power 3 minus 1. This value we need to find. We can write this as also, initially we can ignore this step. This is 1.19 cube minus 11280 is the principal. 1 plus 19 upon 100 whole cube minus 1. So let's apply the digit sum approach. 8 and 1 9, so it's 3. 9 goes out, 1 plus 1 is 2, so it's 2 cube minus 1. So 8 minus 1 is 7, so 3 into 7 is 21. That means digit sum we are looking for 3 in the answer choice. So let's carefully calculate the digit sum of the answer choice. So whenever we are adding up to 9, we will leave that part. 9 goes out, 7 and 2 is 9, 5 and 5 is 10, 1 is left, 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 4 is 11. So 2 left, 2 plus 8 is 10, so 1 is the digit sum. We got 1 as the digit sum. So this is not the answer. So 7 and 2, 9, 9 we can ignore out, 5 and 4 is 9, 8 plus 6 is 14, so 5 is left, 5 plus 3 is 8, 8 plus 1 is 9, so 4 is left. Answer digit sum is 4, so not the choice. Now 7 and 2 is 9, 7 and 2 is 9, so 8 and 5, 8 and 5 is 13, 4 is left, 4 and 9 is 13, 9 we can left out, 8 and 5 is 13, 4 is left, 9 we ruled out, 4 and 3 7, 7 and 5 12, digit sum is 3, so can be our answer. Let's look at the fourth choice. 7 and 2 straight away ruled out, 7 and 2 is 9, 5 and 4 is 9, 6 and 3 is 9, we are left with 5 as the digit sum. 6 and 3 is 9, we are left with 5. So this is also not the answer choice. We had only one answer choice, which is given as choice C as the answer. Yes? So by applying the digit sum, this question becomes much simpler. Let's try this part also. The amount received at 10% per annum compound interest after 4 years is this given value. What is the principal? Principal into 1 plus R upon 100 to the whole power n. This is amount, where R is rate percent per annum and n is the number of years. The amount received at 10% per annum compound interest after 4 years is it the, we have to find the principal, that is P into 1.1 to the whole power 4 is given as 136893.35. 136893.35. We have to find the principal. So once again let's apply the digit sum approach. 1 plus 1 is 1, 2 to the power 4. 6 and 3 is 9, 8 and 1 is 9, 9 goes out, 3 and 3 is 6, 6 we take 6 and 5 is 11, so we are left with 2. So 2 to the power 4 is 16 is equal to 2, 6 plus 1 is 7. So we have digit sum of the answer is 2 by 7. Whenever we had 7 in the denominator, we multiplied by 4 in the numerator and denominator. It becomes 8 upon 28. Digit sum of 28 is 2 plus 8, 10. That is 1. So we are looking for choice whose digit sum is 8. 9 goes out. This is 8. Now 5 and 4, 9. 8 and this is digit sum 5. 9, 5 plus 2 is 7. 9. It's 3. So we had only one choice as left as the answer choice as A choice. So much of time can be saved in this part. Yes. So if we apply carefully this property, much of the time can be saved. This is one of the efficient tool to find the answers by applying the digit sum approach. Yes. Now let's move to the next segment, multiplication by duplex method or cross multiplication method. Now, how do we multiply this part? We do multiplication in a single line. We multiply these two terms. 3 into 7 is 21. We write 1, 2 is the carryover. We will keep on writing the carryover one below the other. If there is no carryover, we put a dash. 3 into 7 is 21. We multiply these two terms, 1, 2 carryover. Then we multiply in cross method. That's called cross multiplication method. 7 into 2 is 14. 1 into 3 is 3. We multiply and add. 14 plus 3, 17 plus carryover 2 is 19. We write 9. 1 is the carryover. So this is 2 by 2. First we have done 1 by 1. That is we multiplied 1 by 1. 3 into 7, 21. 1, 2 carryover. Then we multiplied 2 by 2. 7 into 2, 14. 1 into 3, 3. 14 plus 3 is 17. Plus 2 is 19. 9 and 1 carryover. This is 2 by 2. Then we do 1 by 1. 2 on the 2 plus 1 is 3. This is our answer, 391. So we are starting from this particular side, right hand side. We are doing 1 by 1, then 2 by 2, then coming back to 1 by 1. Let's try this once again. 1 into 3 is 3. This is 1 by 1. We do not have any carryover, we put a dash. 3 into 2 is 6. 1 into 4 is 4. We multiply and add. 6 plus 4 is 10. So we write 0. 1 is the carryover. We have done 2 by 2. Let's move to 1 by 1. 4 to the 8. 4 to the 8. 8 plus 1 is 9. Our answer. We keep on writing carryover one below the other. This is one line multiplication method. So first we do 1 by 1 multiplication. 1 3 the 3. There was no carryover, we put a dash. Then 3 into 2 is 6. 1 into 4 is 4. 6 plus 4 is 10. We write 0. 1 is the carryover. Then 4 to the 8. 8 plus 1 is 9. It's 903 as the answer. Let's try this part. 1 by 1. 7 into 5 is 35. We write 5. So 3 is the carryover. 7 5 the 34. Then cross multiplication. 7 6 the 42. 3 5 the 15. 42 plus 5, 47 plus 10, 57 plus carryover 3, 60, 0, 6 is the carryover. Once again, 7 6 the 42, 5 3 the 15, 42 plus 5, 47 plus 10, 57 plus 3, 60, 0 and 6 carryover. So 2 by 2 done. Now we come to 1 by 1, 6 3 the 18. 18 plus 6 is 24. So 240. Yes. Now let's extend the same result to this part. What we have to do? We have to start from 1 by 1 from the right hand part. Then we keep on increasing. We move to 2 by 2. Then 3 by 3. Then gradually decrease to 2 by 2 and 1 by 1. 1 by 1, 2 by 2, 3 by 3. 2 by 2 and 1 by 1. We will not never writing this cross while solving. 1 to the 2. No carry over, put a dash. This is 1 by 1. 2 by 2. 4. 2 into 2 4. 1 into 1 1. 4 plus 1 is 5. Put a dash. This is 2 by 2. 1 and 4 is 5. We do not have any carry over, so we put a dash. Then 2, 3 by 3 is in this manner. We divide symmetrically. 1 to the 2, 1 to the 2, 1 to the 2. Multiply and add. 2 plus 2 plus 2, 6. We do not have any carry over, 6. We add a dash. Then hide this part. We have to leave this part. Now we have to move to 2 by 2. We will hide the rightmost column. It's 1 1 the 1, 2 to the 4. 4 and 1, 5. We do not have any carry over. Put a dash. Leave this, hide second column also. Now we are moving to last part, 1 by 1. That is 2 1 the 2. Once again, we write this is 1 by 1. 2 by 2 is 4 and 1, 5. No carry over, we keep on putting dash. Then 3 by 3. 2 plus 2 plus 2 is 6. Then we hide the rightmost column. 4 and 1, 5. 2 on the 2. Let's apply in this part. 4 into 2 is 8. So no carry over, put a dash. 4 into 5, 20. 1 into 2, 2. So 22. 20 plus 2 is 22. Single digit, everything else goes for carry forward. We can write only single digit. Then 3 by 3. 4 3 the 12. 6. 3 into 2 is 6. 12 and 6, 18 and 5, 23 plus 2 is 25. 12 plus 6, 18 plus 5, 23 plus 2, 25. 5 and 2 carry over. Now hide this rightmost column, hide this part. We leave this part. 15 and 3. 15 and 3, 18 plus 2, 20. 0 and 2. Now hide this column also. 9, 1 by 1. 3 3 the 9. 9 plus 2, 11. 1 1 0 5, 2. So we keep on moving from right hand side to left hand side. 1 by 1, 2 by 2, 3 by 3 till the maximum we got. Then we reduce. 2 by 2, 1 by 1. Let's once again try this part. 172, 534. 4 into 2 is 8. No carry over, put a dash. Keep on putting carry over one below the other, and if there is no carry over, please put a dash. 4 to the 8. 7 for the 28. 2 by 2, 7 for the 28. 3 to the 6. 28 plus 6 is 34. So 4, 3 carry over. Now 2 by 2 done, we move to 3 by 3. 5 to 10. 5 into 2 is 10. 1 into 4 is 4. So 4 plus 10 is 14. And 7 into 3, 21. 21 plus 14 is 35. Plus 5 plus 3 is 38. So 3 carry over. Now we hide the rightmost column. 35 plus 3, 38. 35 plus 3, 38. Plus 3, 41. 1 and 4 carry over. 5 and the 5. 5 plus 4 is 9. 9 1, 8 4. Yes. So this is multiplication, cross multiplication method or duplex multiplication method. Let's try this further. 7 into 3 is 21. 1, 2 carry over. This is 1 by 1. 2 by 2. 1 7 the 7. 3 to the 6. Multiply and add. 6 and 7 is 13 plus 2 is 15. We write 5. 1 is carry over. 3 by 3. 35 plus 3. 38 plus 2. 40 plus 1. 41. 3 by 3. 35 plus 3. 38 plus 2. 40 plus 1. 41. So 1 and 4 carry over. We have done 3 by 3. We leave the rightmost column. 10 and 1. 11 plus 4. 15. 5 and 1 carry over. 1 5 the 5 plus 1. 6. 5 1 5. Yes. 2 into 3 is 6. No carry over. 9 into 11. 1 and 1 carry over. This can be done much faster. 9 into 11. 1 and 1 carry over. Then 3 by 3. 12 plus 4. 12 plus 4. 16. 3 19. Plus 1 20. 0 and 2 carry over. Now we have done 3 by 3. 12 plus 4 16 plus 3 19. 19 plus 1 20. 0 and 2 carry over. Now hide the rightmost column. 6 plus 4 10 plus 2 12. 2 in 1 carry over. 4 into 2 8. 8 plus 1 is 9. 9 to 0 1 6. Yes. Let's try this part. 232 123. 3 into 2 is 6. No carry over. 9 and 4 13. 3 and 1 carry over. 6 and 2 8 and 6 14 plus 1 15. 5 and 1 carry over. This is 3 by 3. 6 into 8 plus 6 14 plus 1 15. 5 and 1 carry over. Now hide the rightmost column. 4 and 3 7 plus 1 8. Please don't forget to add dash, otherwise we will add the same remainder next time also. 4 plus 3 7 plus 1 8. Carry over used, no carry over. Then 2 on the 2. Yes. 2 into 3 6 dash 8 and 15. 15 plus 8 23. 3 and 2 carry over. So 3 by 3 6 and 2 8 and 20. 28 plus 2 30. 0 and 3 carry over. 2 and 6 8 plus 20. 28 plus 2 30. 0 and 3 carry over. Now hide the rightmost column. 8 plus 5 13 plus 3 16. 6 and 1 carry over. 2 into 1 2 plus 1 3. So 3 6 0 3 6. Let's try this part. 4 into 2 is 8. No carry over. 28 and 6 34. So 4 and 3 carry over. This is 2 by 2. Then 3 by 3. 10. 5 into 2 is 10. 1 into 4 is 4. 10 plus 4 is 14. 7 into 3 is 21. 14 plus 21 is 35 plus 3 is 38. Again 3 carry over. Now we leave the rightmost column. 35 plus 3 38. 35 plus 3 38 plus 3 41. 1 and 4 carry over. So 5 and 4 is 9. 9 1 8 4 8. Yes. You have to practice this. Now let's try with 4 by 4. We have to do 1 by 1, 2 by 2, 3 by 3, 4 by 4. Then reduce to 3 by 3, 2 by 2, 1 by 1. Let's see. 1 into 2 is 2. Sir, no carry over. 2 by 2, 4 and 1. 4 and 1 is 5. 3 by 3, 2. 2 and 2. We are doing this. 2, 2 and 2. So 2, 2 and 2 becomes 6. So we can write this as 6 in this part. So no carry over. Then 4 by 4. Extreme together 1 and 4, 5. 4 and 1, 5. 5 and 5, 10. 0 are first carry. It's 4 by 4. 4 and 1, 5. 1 and 4, 5. 5 plus 5 is 10. 0 and first carry. Hide this rightmost column. It's 2 plus 2 plus 2, 6. 3 by 3. 2 plus 2 plus 2, 6. And 1, 7. Carry over used up, no carry over. We put a dash. Hide the second column. Now consider this part. 2 by 2. 4 and 1, 5. No carry over. 1 to the. So it's 2570, 652 as the answer. So we are starting with 1 by 1, then we are starting with 2 by 2, 3 by 3, then symmetrically 4 by 4. Then reduce to 3 by 3, 2 by 2, 1 by 1. We never write these symbols, we directly apply. Let's try this number. 5 into 3 is 15. Sir, 1 carry. 15 and 12. 15 and 12 is 27. Plus 1 is 28. Sir, 2 carry. 1 3 the 3. 5 to the 10. 13. 10 and 3 13. Plus 12. 25. Plus 2 27. 7 again 2 carry. We have done 3 by 3. 10, 3, 13 and 12, 25 plus 2, 27, 7 and 2 carry. Then 4 by 4, 5 4 the 20, 3 into 3 is 9, 29, plus 3, 32, plus 8, 40 and 2, 42, 2, 4 carry. Once again, 5, 4, 20, 3 into 3, 9, 29 and 3, 32 and 8, 40 and 2, 42, 2 and 4 carry. Now leave the rightmost column. Now move to 3 by 3. 16 and 9, 25 and 2, 27 plus 4, 31, 1, 3 carry. 16 plus 9, 25 plus 2, 27, 4, 31, 1 and 3 carry. Leave the second column also. 4 and 6, 10 and 3, 13, 3 and 1 carry. 4 into 3, 12 and 1, 30. So 1, 3, 3, 1, 2, 7, 8, 5 as the answer. Yes? Now let's try this case also when digits are 4 into 3 multiplication. So what we do? We put a 0 here. 8 into 3, 24. 2 carry. 8 for the 32. 3 to the 6. 32 plus 6, 38 plus 2, 40. 0, 4 carry. 8 into 2, 16. 3, 19. Plus 8, 27. Plus 4, 31. 1, 3 carry. Once again, 16, 3, 19, 8, 27. Plus 4, 31, 1 and 3 carry. Now move to 4 by 4. 8 into 0 is 0. 9. 4 and 4, 8. So 9 and 8 is 17. This is 0, 4 by 4. 0. 8 into 0 is 0. 3 into 3 is 9. We had 9 and 4. 13 and 4. 17 and 3. 20. 0 and 2 carry. Now from 4 by 4 we move to 3 by 3. We leave the rightmost column. This is 0, 12, 3 into 4, 12, plus 2, 14, plus 2, 16, 6 and 1 carry. Yes, what we have done 0 plus 12 plus 2, 14 plus 2, 16, 1 carry. Now move to 2 by 2. 3 into 2, 6. 1 into 1, 0 is 0. 6 plus 1 is 7. No carry. 1 by 1 is 0. So it's 7, 6, 0, 1, 0, 4. This is multiplication by duplex or cross multiplication. It's a faster approach if you practice this. Now let's try multiplication by base method. Now we have to multiply 113 by 118. Let's take base in this case when the numbers are nearer to the powers of 10. We take base as 100. So this is 13 more than 100. This is 18 more than 100. We just multiply these two numbers. 18 into 13. 18 into 10 is 180. 18 into 3 is 54. So it's 234. We write product of these two numbers with sign. Now we add these two numbers, whether we add 118 plus 13 or 113 plus 18, we give the same result. So it comes out to be 131. Now whatever number of zeros are there in the base, we will keep the same digits other are being taken as carry. So it's 34, then 2 goes carry over, it becomes 1, 3, 3, 3, 4 as the answer. 1, 3, 3, 3, 4 as the answer. Straight away multiplication. When numbers are near to the powers of 10. So this is 13 more the initial 100, this is 18 more. We multiply these two numbers, 18 into 13 is 234. Then we add, either we add 113 plus 18 or 118 plus 13, we get the same result. Now whatever the number of zeros are there in the base, we will keep the same digits, other will be taken as carry forward. So it's 1, 3, 3, 3, 4. Let's try this example. We take base as 100. These numbers are nearer to 100. So this is plus 9, this is minus 7. So we multiply them and keep them with sign. This is minus 63. 93 plus 9 is 102 or 109 minus 7 is 102. Now we have to keep this as positive, so we borrow from this side. So base is borrowed, 1 is borrowed, 100. So 100 minus 63, we left with 37. And we will keep the same number of digits as zeros are there in the base. So this is 101 as 1 is borrowed. So answer is 10137. You have to keep this in sign also, mind. This is plus, then 100 plus 9, this is minus 7. So 9 into 7 is minus 63. We keep with sign. And whether we add 109 with minus 7 or 93 plus 9, we will get the same value. 93 plus 9 is 102. Now since this part is negative, we have to make it positive by taking a borrow. We take a base as borrow. 102 is there, so we take 100 as borrow. So from 163 is subtracted, we get 37 and 101 is left. And in base we have 2 zeros, so we take 2 digits in this part. So answer is 10137. Let's try this part. This number is base is, we are taken base as 100. So we are using base method when the digits numbers are near to powers of 10. So this is plus 70 and this is minus 12. 17 into 10 is 170, 17 into 2 is 34. So 170 and 34, we are adding this, they get as minus 204 with sign. Now whether you add 117 minus 12 or 88 plus 17, you get the same value. So this comes out to be 104. Now base was 100 in this case. Now we have to borrow 300 from this. So this becomes, when you borrow 300, so 300 minus 204 is 96. So 2 digits are there, 96, and 3 is borrowed. So we got answer as 10296. Yes? In this case, we have taken base as 1000. They are nearer to 1000, 10 to the power 3. So this is minus 3, this is minus 70. So we multiply 17 into 3, 51. But please keep the same number of digits as the number of zeros in base. 17 into 3 is 51. So we write 051. Now 983 minus 3 or 997 minus 17. Both gives us the same value as 980. So number of zeros are 3. We had 3 digits. So answer is 980051. 980051. Yes? No. Let's try this. We take base as 1000. This is plus 30 and this is minus 90. So 19 into 10 is 190. 19 into 3 is 57. So we got 247 with minus sign. 1013 minus 19. 1000 minus 13 minus 19 or 981 plus 13 is 994. But this side is negative. We have to make it positive. So we take 1. Base is 1000. So it's 993 is left and 1000 minus 200 is 800 minus 47 is 753. and we have to take the same number of digits as zeros in the base, that is 3 digits. So answer is 993753. Yes. Now let's try when base is not 100 or 1000, it's something else. In this case, these numbers are nearer to 300. So we take base as 300. So this is 3 less than 300. This is 8 less than 300. 8 minus 3 into minus 8 gives us 24. 297 minus 8 or 292 minus 3 gives us 289. This base was taken as 3 into 100. So before doing any part, just multiply this by this number 3. That means when base is a into 100, we multiply by a. So 200 into 3 is 600, 80 into 3 is 240, so 840, 9 into 3 is 27. So this is 867, oblique 24. Take the same number of digits as they are in the base, so this gives us 86724. Yes, when base is a into 100, so we get the same value in the method, but we multiply it by a before adjusting the terms. Take this part, we again take base as 300 in this case. This is 3 into 100. So this is 13 less than 300 and this is 19 less than 300. So 19 into 13 both are negative, so we get 247 is positive. Now 287 minus 19 is 268. But first multiply this by 3. So 268 into 3 we have to do. It's 200 into 3 is 600, 60 into 3 is 180, 780, 80 into 3 is 24. So this is 804 and 247. Now we can keep only 2 digits as there are 2 zeros. So this 2 will go for carryover. So it becomes 804 plus 2 is 647 as the answer. Don't forget to multiply it by 3, that is a into 100. Base is 300 in this case, 3 into 100. This is 17 more, 1 more than the base, other less than the base, minus 9. So this is minus 153. Now 317 minus 9. 317 minus 9 or 291 plus 17 is 308. First multiply this by 3. So it's 924 and minus 153. Now this part is negative. We need to make it positive. So we borrow 200 from this part. So 200 minus 153 is 47. So it's 922 because we borrowed 200 and 47. Now base has 2 zeros. So 2 digits we can take. So it's 92247. Multiplication of 317 into 291. Yes. Let's take another part. When base is, in this case, base is 500. They are closer to 500. That is 5 into 100. So we don't forget to multiply it by 5. So what we do, this is plus 30. This is minus 22. So minus sign will be there. Multiply these two terms. Minus sign will be there. 22 into 10 is 220. 22 into 3 is 66. So this is minus 286. Whether you do 478 plus 13 or 513 minus 22, we get 491. Multiply this by 5 first. So 400 into 5 is 2000, 90 into 5 is 450, 2450 and 1 into 5 is 5. So it's 2455 and then minus 286. Now we have to make it positive this part, so we take 300 as the borrow. So it becomes 2452. 300 minus 286 is 40. Number of zeros in the base is 2, so we add 245214. So it's 245214 as the answer. Let's try one more part. It says 979 into 92. So what we do? This number is closer to 1000, this is 100, we put a 0 in this part. So whatever answer we get, we'll divide the answer by 0. So now we take base as 1000. Don't forget to divide by 0 here, the answer which you got, that is by 10. So this is 979, that is minus 21 then base, 920 minus 80 then base. So minus into minus is plus, this is 1680. 979 minus 80 is 899, or we can do 920 minus 21. Now first, this is 899, this is 1680. Now, how many digits are there in the base? Zeros are there in the base? 3. So we can take 3 digits. So this goes for carry on. So what we get? 680 in this part. 9 plus 1 is 10, 0, 9. So 900, 680 is the answer when you multiply 97 by 920. That are required answers. Required value or correct answer we can say is you have to divide this by 10 because you multiplied this by 10. So answer is 90068 as the answer. 90068 as the answer. Yes. Now, how many digits will be there in the answer when we multiply these two digits? So we can use another point to remember how many digits will be there in the answer. Now, number of digits changes from 1 to 2. When it's 3 square, we move from 3 square, that is 9 to 4 square. Digit changes from 1 to 2. So number of digits changes from 2 to 3 when we move from 9 square, that is 81, to 10 square, that is 100. Number of digits in the answer will be from 3 to 4, changes from 3 to 4 when we multiply 31 square to we move to 32 square. This is 961, this is 1024. 3 digit, 4 digit. So how many digits are there will be in the answer? We can also cross check our answer by using this table. The number of digits changes from 4 to 5 when we move from 99 square to 100 square. Now answer contain 4 digit or 5 digit. We have to check whether we are multiplying 99 square or less number which are less than this or 100 square. Now, 5 to 6, if we need number of digit changes from 5 to 6 when we are multiplying 316 square to 317 square. Digit 5 to 6. 316 square is 99856 and 31 square is 10048. And number of digit changes from 6 digit number to 7 digit number when we move from 999 square to 1000 square. 999 square to 1000 square. So we can remember this when we are using a base method, how many digits will be there in an answer. So from 1 to 2, 1 digit number, 2 digit number, 3 square to 4 square. 2 to 3, 9 square to 10 square. 3 digit number to 4 digit number, 31 square to 32 square. Suppose we are multiplying 31 into 30. So we know our answer has to be a 3 digit number. 4 digit to 5 digit, 99 square to 100 square. 5 digit to 6 digit, 316 square to 317 square. So if we are multiplying 314 by 313, we know our answer has to be a 5 digit number. Because from 5 digit, it will be when multiply 316 by 316. And if we move to 317 square, it becomes a 6 digit number. So any multiplication of the number of 318 into 320 will be a 6 digit number. We can use this table also. And 6 digit to 7 digit, when we are doing from 999 square to 1000 square. So this can also be remembered as how many digits would be there in the resultant answer when we are using a base method. This can also be learned. Yes? So moving to the next segment, how to find square of any number which ends with 5. So if it says n5 square, so last two digits are by default 25. We are multiplying n by n plus 1. Let's try this. Ends in 5. So last two digits are 25. What is next higher to 1? That is 2. 1 into 2 is 2. Ends with 5. So 25 by default last two digit. What is next higher to 2? It's 3. So we multiply 2 into 3 is 6. 35. 25 last two digit. What is next higher to 3 is 4. So 3 into 4 is 12. We are using this part n into n plus 1. Last two digit will always be 25. Let's try this part. 45 square. So 25 last two digit. 4 next higher to 4 is 5. 4 into 5 is 20. 55 square. It's 25. Next higher to 5 is 6. 5 into 6 30. 65 square. 25. Next higher to 6 is 7. 6 7 the 42. 75 square. It's 25. Next higher to 7. 7 8 the 56. 85 square, that is 25 last two digit 8, next higher to 8 is 9. 8 9, 8 into 9 is 72. 95 square, 25 for sure, next higher to 9 is 10. 9 into 10 is 90. 105 square, 25, next higher to 10 is 11. 110 25. 115 square, we need to find 115 square. So 25 are there for last two digit. Now we need to multiply 11 by 12. So any number to multiply by 11, just stretch the two numbers, write their sum in between. It's 1, 3, 2, 2, 5. Any number to multiply by 11, just stretch the two numbers, write their sum in between. Suppose we need to multiply 23 by 11, just stretch these two numbers, write their sum in between, 253. Now 125 square we need to find, 25. Now we need to multiply 12 by 13. 12 into 13, that is 12 plus 1. 12 into 12 is 144 plus 12, 156. So this is 156 and then 25. So answer is 15625. So what we learn in this slide, we have to find square of any number which ends in 5. So it's 25 last two digit, then we have to go for n into n plus 1. N into n plus 1, then 25. Yes? 15 square, 25, 1 into 2. 25 square, 25 last two digit, 2 into 3, 6. 35 square, 25, 3 into 4, 12. 45 square, 25 last two digit, 4 into 5 is 20. 55 square, 25 last two digit, 5 into 6, 30. 65 square, 25 last two digit, 6 into 7, 42. 75 square, 25 last two digit, 7 into 8 is 56. 85 square, that is 25. 8 9 the 72. Multiply 8 by next higher number, 8 into 9. 95 square, 25, 9 into 10 is 90. 105 square, it's 25, 110, 10 into 11. 115 square, 25 last two digit, 11 into 12. Any number multiply by 11, just stretch the two numbers, write their sum in between, 132. 2 plus 1 is 3. 125 square, 25, then 12 into 13, that is 12 into 12 plus 1. 12 into 12 is 144, 12 into 1 is 12. So it's 156, 25. Yes. Now square of any number ending in 1, ending with 1. Simple formula is it's 1 2a square. If we are finding square of a1 square, just see 1, a is 1, double 1 is 2, square of 1 is 1. 21 square, 1, 2 into 2, 4, square of 2 is 4. 31 square, 1, double of 3 is 6, square of 3 is 9. 41 square, 1, double of 4 is 8, square of 4 is 16. 51 square, 1, double of 5 is 10. We have to write single digit, 0, 1 is carry over. Square of 25, 5 is 25, plus 1, 26. Once again, if you wish to find square of 31, it says 1 2a square, square of number which ends with 1. So it's 1, double of 3 is 6, square of 3 is 9, 961. Square of 41, 1, double of 4 is 8, square of 4 is 16. Square of 51, it's 1, double of 5 is 10, 0, 1 carry over. Square of 5 is 25, plus 1, 26. Let's try square of 61, 1, 6 into 2 is 12, 2, 1 carry over. 6 square is 36, plus 1 is 37. 1, double of 7 is 14, single digit 4, 1 is carry over. 7 square 49, plus 1 50. So 5041 is the square of 71. 81 square, 1, double of 8 is 16, 1 carry over. 8 square is 64, plus 1 65. 1, double of 8 is 16, 6, 1 carry over. 8 square is 64, plus 1 is 65. 91 square, 1, double of 9 is 18, 8, 1 carry over. Square of 9 is 81, plus 2 plus 1 is 82, 82, 81. So 91 square is 1, double of 9 is 18, 8, 1 carry over. 9 square is 81, plus 2, 82, 81. So this is how do you find square of any number which ends in 1. Yes? Let's take it further. Square of any number from 1 to 100. Suppose we wish to find square of 19. So what we do, we write square of this number 01, square of this number 81, and we multiply these two numbers, 1 into 9, these two digits, 1 into 9, 9, and into 2 is 18. We write 18 just leaving the last digits. This is 1, then we add 8 and 8, 16, 1 carry over, 361. Once again, if you want to find square of AB, we write square of this number as a 2-digit number, square of this number as a 2-digit number, and then add 2AB, just keeping the last digit, leaving the last digit. So 19 square. What is square of 1? 01. What is square of 9? 81. Then 2 into A into B, that is 18. We write just leaving the last digit and then simply add. It's 1, 6, 361. We can write square of any number. So let's try for 37. 3 square is 09. 7 square is 49. 7 into 3 is 21. Double is 42. Just leave the last digit and then simply add. It's 9, 6, 3, 1. Very simple. Once again, 37 square. 3 square is 09. 7 square is 49. Now we have to add 2ab. 7 into 3 21 into 2 42. Just shift one space and add 9 6 3 1. Let's try for 42 square. But we write square is 2-digit number. 42 square. 4 square is 16. 2 square is 04. 4 into 2 8 into 2 16. Just leave the last digit. It's 4 6 7 1 1764. Yes. So what we are doing? We wish to find square of AB. We are writing square of A as a 2-digit number, square of B as a 2-digit number, and then add 2AB. But keeping in mind, we are not writing from this part. So square of 42 is 1764, square of 37 is 1369, square of 19 we know is 361. Let's practice more numbers. 53 square. So it's 2509. 5 into 3 is 15. Double is 30. It's 908. 2809. Very simple. Once again, 53 square. 5 square is 25. 3 square is 09. Then we multiply these two numbers. 5 into 3 15. Double is 30. Just leave the unit digit. Just add them. 2809. Let's try for 67 square. 6 square is 36. 7 square is 49. 6 into 7 is 42. Double is 84. Just add 84. It's 9, 8, 14, 4, 4, 8, 9. Let's try for 84 square. 8 square is 64. 4 square is 16. 8 into 4 is 32. Double is 64. Just add, leaving one rightmost digit. It's 6, 5, 10, 7, 0, 5, 6. Let's try once more with 67 square. We had calculated 67 square. Let's try once more for 67 square. It's 67 square. 6 square is 36. 7 square is 49. 7 into 6 is 42. Double is 84. So 9, 8, 4, 4, 8, 9. 4, 4, 8, 9. We just add these two parts. Yes. Now square. Let's try more examples. It says 93 square. So 9 square is 81. 3 square is 09. 9 into 3 is 27. Double is 54. It's 9, 4, 6, 8. We just add. So it's 8, 6, 4, 9. Yes? 8, 6, 4, 9. 93 square. 9 square is 81. 3 square is 09. Writing two digits. And 9 to 3 is 27. Double is 54. Just add, leaving the right place. It's 9, 4, 6, 8. 8, 6, 4, 9. Let's try 62 square. It's 36, 04. 6 square is 36. 2 square is 04. Now 6 into 2 is 12. 12 into 2 is 24. It's 4, 4, 8, 3. 3, 8, 4, 4. So we add 3, 8, 4, 4. 54 square. 5 square is 25. 4 square is 16. 5 into 4 is 20. Into 2 is 40. 6, 1, 9, 2. 2, 9, 1, 6. So can be found much faster. 2, 9, 1, 6. Yes? Now we wish to learn square from 1 to 1000. We wish to write any number. Let's try from 100 to 1000. It says 112 square. So we try to make this nearer to 100 or 200. If we add this 12 and subtract 12, so it will, one part will become 100. So what we do, in 112 it's 112 square, in one we add plus 12, other we subtract 12. So 112 with plus 12 is 124 and 112 minus 12 is 100. And second part is square of this, what you have added and subtracted. 12 square is 144. We have to find square of 112. So we try to make it nearer to the 1 with powers of 10. So it's 112, we added 12 and subtracted 12. So 112 plus 12 becomes 124, 112 minus 12 becomes 100. And second part is square of this number, what you are adding and subtracting. 12 square is 144. Now, it has two zeros, so we'll keep two digits. So rest will come as a carryover to the left hand side. So it's 124 oblique 144. We have to keep two digits, so this will come as carryover. So answer is 12544. Let's try once again. Let's try for 171 square. So we add plus 29, we add minus 29. It's 171 square. On one term we add plus 29, other term we subtract 29. So 171 plus 29 becomes, one part becomes 200, minus 29 becomes 142. And second part is square of 29. Square of 29 is 841. Now there are two zeros, so we cancel out these two zeros, we will keep these two digits. Now we have to multiply 142 by 2. 142 by 2 becomes 284. 841. We can keep only two digits, so this goes for carryover. So 41, 8 plus 4 is 12. So 29241 is my answer. Let's try once again. We have to find square of 171 squares. So in one term 171 we had added 29 to make it to near powers of 10, that is 200. Other we subtracted 29. So 171 plus 29 becomes 200 and 171 minus 29 becomes 142. And second part will be square of 29. Square of 29, if you wish to find square of 29, this is 841. Now the number of zeros are there on the left part, we will take the same number of digits. So two digits. But we have to first multiply this by 2. So 142 into 2 becomes 284 and this is 841. We can take only two digits. So 41 will be there, 8 goes for carryover. So 41, 8 plus 4, 12, 1 carryover, it's 29245. In this manner we can write square of any number. Let's take more numbers. 287. We have to find 287 square. Either you multiply 287 by base method, or what we had done, we had added 13 and subtracted 13. So the second part is square of 13, which is 169. 287 plus 13 is 300. 287 minus 13 is 274. So the number of zeros in the left part is equal to the number of digits we have to take from this second part, 69. But first multiply this by 3. 200 into 3 is 600, 70 into 3 is 210, 810, 4 into 3 is 12. So we can say 822 oblique 169. But we have to keep two digits, so one will goes as carryover in this part. So it becomes 82369. Yes. Let's try for 876 square. So on one part we add 24. So in the other part we subtract 24. So 876 plus 24 becomes 900. 876 minus 24 becomes 852. And second part is square of 24, which is 576. Since there are two zeros, we remove these two zeros, we take two digits. We have taken two digits. The number of zeros in the left part, we will take the same digits, same number of digits from the right part. Now first we have to multiply this by 9. 800 into 9 is 7200. 50 into 9 is 450, so 7650. 9 into 2 is 18, so 7668. And then we add 576. This 76 will be there, 5 goes as carry. So 76, 13, 7, 6, 7. So it's 767376 as the answer. 767376 as the answer. Yes. Let's do one more time. 912 square. So 912 square, on one part we add 12, other part we subtract 12. So 912 plus 12 is 924. 912 minus 12 is 900. And in the second part we add square of 12, 144. Since there are two zeros we have in the left part, so we can keep only two digits from the right hand part. But first we have to multiply this by 9. So 900 into 9 is 8100, 20 into 9 is 180, and 9 into 4 is 36. This is 8316. Then we add 144. We can keep only two digits, so it's 44. 1 goes as carry over to 6. So it's 831744. 831744 as the answer. Yes, this part clear? So in this way we can write square of any number from 1 to 1000. We are dividing into two segments, from 1 to 100 and then from 100 to 1000. Multiplication of a number by 11. Just stretch the two numbers, write their sum in between. 23 into 11 is 253. Sum of 2 and 3. 43 into 11 is 4 plus 3 is 7. 473. What we are doing right now? Multiplication by 11. 83 into 11, 8 and 3. 8 plus 3 is 11. 1 and 1 goes as carry over. This is 913. You just stretch the two numbers, write their sum in between. 92 into 11, 9 and 2 create a vacant space. 9 plus 2 is 11. So 1 carry over. So 9 plus 1 is 10. This is 1012. So what we are doing, suppose 25 into 11, it's 2, 5, their sum in between, 273. 71 into 11, 781, just write their sum in between. Yes? Now let's try when a number is of more than 2 digits. It says 1, 2, 3, 4, 5 by 11. Keep this least significant digit as it is, most significant digit as it is. 5 plus 4 is 9. 4 plus 3 is 7. 3 plus 2 is 5. 2 plus 1 is 3. Done. Answer is 135795. Just keep the least significant digit and the most significant digit as it is. Just start adding one by one. Take a pair. 5 and 4, 9. 4 and 3, 7. 3 plus 2, 5. 2 plus 1, 3. This is multiplication by 11. Let's try this part. 4, 1, 2, 7, 5, 3 by 11. This 3 as it is, this 4 as it is. 5 plus 3 is 8. We don't have any carry over. 7 plus 5 is 12. We can write only single digit. 1 is carry over. 7 plus 5 is 12. 2, 1 carry over. 7 plus 2 is 9. Plus 1, 10. 0. 1 carry over. 2 plus 1 is 3, plus 1 is 4, carry over gone. Use the carry over. 1 plus 4 is 5. So 4, 5, 4, 0, 2, 8. We add one by one, taking a pair, and if we have carry over, we will keep them adding. So 3 and 4, we keep it as it is. What we have done, 3 plus 5 is 8, 5 plus 7 is 12, 1 carry over, 7 plus 2 is 9, plus 1 was carry over, 10, 0 and 1 carry over, 2 plus 1 is 3, 3 plus 1 is 4, so we put a dash, carry over finished. Then 1 plus 4 is 5, it's done. 4, 5, 4, 0, 2, 8, 3. Let's try 8, 2, 9, 8, 3 by 11. We keep this 3 as it is, we keep this 8 as it is. Now 8 plus 3 is 11, single digit, 1, 1 carry over. 8 plus 9 is 17, plus 1 is 18, 1 carry over. We keep carry over one below the other. 9 plus 2, 11, plus 1, 12, 1 carry over. 9 plus 2, 11, plus 1, 12, 1 carry over. 8 into 10, plus 1, 11. Now last carry over goes on 8. So it's 9, 1, 2, 8 plus 1 is 9, 9, 1, 2, 8, 1, 3, 9, 1, 2, 8, 1, 3 as the answer. Yes? Clear? So any digit number multiplied by 11, we can use this part. But whenever we need to increase a number by 10%, indirectly we are multiplying by 1.1. So we multiply by 1.1 and then shift decimal one place to the left. Now, square of a number by duplex method. Now, what is the method? It says we have to multiply AB by AB, square of a number, AB by AB. So it's B square, then AB and AB, 2AB and then A square. So we can write this straight away. It's B square, AB and AB is 2AB and then A square. Here A is 1, B is 4. So it's B square, 16, 1 is carry over. 2AB, 2 into 1 into 4, 8, plus carry over 1, 9 and 1 square is 1. Straight away we can write square of a number as A square, 2AB, B square. 4 square, 16, 1 carry over. 4 into 3, 12, double is 24, plus 1, 25, 2 is carry over. 3 square, 9, plus 2, 11. Once again, 4 square is 16, 1 carry over. 2AB, 4 into 3, 12, double is 24, plus 1, 25, 2 carry over. 3 square, 9, plus 2, 11. Let's try this part. 42 square. 2 square is 4, this is B square. 2AB, 4 into 2, 8, 8 into 2, 16, 6, 1 carry over. 4 square, 16, plus 1, 17, it's 1764. So we can write this straight line. It's 2 square, 4, 2AB, 4 into 2, 8, double is 16, 6, 1 carry over. 4 square, 16, plus 1, 17. 53 square, 3 square is 9. 5 into 3, 15, double is 30, 0, 3 carry over. 5 square is 25, plus 3, 28. 28, 0, 9. Here A is 5, B is 3. B square, 9. 2AB, 5 into 3, 15, double is 30, 0, 3 carry over. 5 square is 25, plus 3, 28. 67 square, 7 square is 49, 4 carry over. 7 into 6, 42, double is 84, plus 4, 88. We write 8, carry over is again 8. 7 into 6, 42, double is 84, carry over was 4, 88, 8 carry over. 6 square is 36, 36 plus 8, 44, 4, 4, 8, 9 is 67 square. 84 square, 4 square is 16, 1 carry. 8 into 4 is 32, double is 64, plus 1 is 65, 5, 6 carry. 8 into 4, 32. It's initially 4 square is 16, 1 carry over. 8 into 4, 32, double is 64, plus 1 is 65, 5, 6 carry over. Keep in your mind, 8 square is 64, 64 plus 6 is 70, 7056. 91 square, 1 square is 1, 1 into 9 is 9, double is 18, so we add 8, 1 carry over. 9 square is 81, plus 1 is 82. 1 square is 1, 1 into 9 is 9, double is 18, 8, 1 carry over. 9 square is 81, plus 1 is 82. 99 square, 9 square is 81, 1 carry over is 8. 9 into 9, 81, double is 162, plus 8, 170, 0, 17 is carry over. 9 square is 81, 81 plus 17, 81 plus 17 is 98, 980. Once again try the last part. 9 square is 81, 1 carry over is 8. 9 into 9, 81, double is 162, 162 plus 8 is 170, 0, carry over is 17. 9 square, that is a square, 81, 81 plus 17 is 98, 9801. We can straight away write in a single line square of a number by using duplex method. I hope this part clear to everyone in the class. Yes? Let's try for the same method for the numbers. 124 square. It's a 3-digit number. What the basic formula is? How do we multiply this by duplex method? If you remember, that is your basic formula. It's c square 2bc. It's 2ac plus b square. 2ac plus b square. 2ab a square. C square 2bc. You remember these steps. It's 2ac plus b square. Square of middle number plus twice the product of other numbers. Then 2ab, then a square. Let's try this part. 124. C square 16, 1 carry. 2bc. 4 into 2 8, 8 into 2 16, plus 1 17, 7 1 carry. Then square of middle number 4, double of these two numbers 8, 8 plus 4 12, plus 1 13. We had 1 in the carry over, 3 1 carry over. This part is done. Then 2ab, 1 into 2 is 2, double is 4, plus 1 is 5, carry over is gone. Then 1 square. Let's try one more time. 124 square. C square is 16, 1 carry over. 2bc, 4 into 2 8, double is 16, plus 1 is 17, 1 carry over. Then square of middle number 4, this is b square, plus 2ac, 4 into 1 4, double is 8, 8 plus 4 12, plus 1 13, carry over was 1. This is done. Then 2ab, ab is 2, double is 4, plus 1 is 5. Then a square, that is 1. We can straight away write this one. Let's try for other part. 4 square is 16, carry over is 1. 2bc, 4 into 2 8, plus 1 is 9, carry over gone. Now square of middle number 1, 4 into 3 12, double is 24, plus 1 is 25, carry over is 2. Then 2ab, 3 into 2 6, plus 2 8. Then square of a square, that is 9, 98596. Let's try once more. 314 square. 4 square is 16, 1 carry over. This is c square. 2bc, 4, double is 8, plus 1 9, no carry over we have. Then 1 square is 1, 4 into 3 12, double is 24, plus 1 25, 5, 2 is the carry over we have. Then 2AB, 3 into 2 6 plus 2 8, carry over gone. Then 3 square is 9, 9 8 5 9 6. Let's try this part. 2 square is 4. 2BC, 6 double is 12. So we write 2, carry over is 1. Then 3 square 9. 4 into 2 8. 8 double is 16. Plus 9 is 25. Plus 1 is 26. 2 carry over. This is 3 square 9. 8 16. 16 plus 9 25. Plus 1 26. 6 into carry over. Now 2 is 2AB. 12 double is 24. Plus 2 26. 6 into carry over. 4 square 16. Plus 2 18. 1866 24. 1866 24. We can multiply by duplex method in a normal manner also. This can be done straight away mentally. Let's try 543 square. 3 square is 9. 4 into 3 12. Double is 24. Carry over is 2. 4 square 16. 5 into 3 15. Double is 30. Plus 16 46. Plus 2 48. Carry over is 4. Once again. 4 square is 16. 5 into 3 15. Double is 30. Plus 16 46. Plus 2 48. 8 4 carry over. Now 2AB. 5 4 that 20. Double is 40. Plus 4 44. 4 4 carry over. 5 square 25. A square. Plus 4 29. 2948 49. 2948 49. Square of 543. Yes? Clear? Now let's try to find square of a number by base method. How do we apply by base method? 14, 14. We take base as 10. So this is plus 4, this is plus 4, this is 16. 14 plus 4 is 18. But since base contain 1 0, we keep one digit. This goes for carry over. So 196. This is by base method. Let's say 97 square we need to find. We take base as 100. So this is minus 3, this is minus 3. Since there are two zeros, we have to keep two digits. So 3 into 3 is 9. We will keep 0 9. 97 minus 3 is 94. So answer is 9409. Let's see for 102. 102 base is 100. This is plus 2. This is plus 2. Base contain two zeros. So 2 into 2 is 4. We write 04. 102 plus 2 becomes 104. So answer is 10404. Yes. Let's try for 207. Base is 200. That is 2 into 100. This is plus 7. This is plus 7. So we say 49. 207 plus 7 is 214. But first we have to multiply this by 2. 214 double is 428. 49. Base contain two zeros. So answer is 42849. Yes. Let's try for 308. We take base as 300. So it's plus 8 plus 8. 8 into 8 is 64. 308 plus 8 is 316. Before doing anything, first you need to multiply by a into 100. That is a, 3. So it's 948. 64. Base contain two zeros, so two digits will be there. So it's 94864. Or we can also use that table to find how many digits are there in the resulting sum. So this is 94864. This is 308 square. Let's try for 414. We take base as 400. So it's plus 14 plus 14. We can say 196. Square root of 14. 196. 414 plus 14 is 428. We need to multiply this by 4. So it's 16. 400 into 4, 1600. 20 into 4, 80. 8 into 4, 32. That is 17, 12, 196. Since base contains 2 zeros, we can take 2 digits. This one will go as a carrier. So it's 171396. 171396. I hope this part is clear. Yes. Let's try for 998 square. We take base as 1000. So this is minus 2, minus 2. But base contains 3 zeros. So 2 into 2, 4. Minus minus become plus. So we write 0, 0. 998 minus 2 is 996. The number of zeros are there in the base. We keep the same number of digits in the second part. So it's 3. So answer is 99600. It's a 6-digit number. Yes. Now how to find cube of a number starting with 1. Suppose we need to find cube of 1a cube. So what we do? We write 1a square, a cube. Then add, write double of this number and simply add. Let's see. Starting with 1. 1a square, a cube. Double of these two middle numbers, simply add. 8, 12, 7, 1. 1728. Straight away we can write cube. Let's try for 13 cube. A is 3. 1, 3, 9, 27. Double of these numbers, 6 and 18. Add. It's 7. Single digit we have to take in. 2 goes carry over. So 18 plus 2 is 20 plus 9 is 29. 2 carry over. 6 and 3, 9 plus 2, 11. It's 2197. So 13 cube is 2197. Let's try for 14 cube. 14 cube is 1a square, a cube. Just double of these two middle numbers, 32, and add. It's 4. 6 goes for carry over. 16 plus 32 is 48. Plus 6 is 54. 4 and 5 carry over. 8, 4, 12 plus 5 is 17. 1. It's 2744. That is 14 cube is 2744. Let's try for 15 cube. 1a square, a cube. Double of these numbers, middle numbers, and add. 5, 12 is carry over. This goes to 12 as carry over. We will take single digit. So 75, 12, 87, 7 and 8 carry over. 8, 5, 13 plus 10, 23, 3 and 2 carry over. It's 3375. So cube of 15 is 3375. So what is the shortcut? We write 1a square, a cube, and double of middle two numbers, 2a square, and just add all these values. Yes. So we write in this manner: 1a square, a cube, and double of middle two numbers. Cubes of number ending with 1, that is a1 cube. We write in the same logic, but we will start in the reverse order. 1a, a square, a cube, and then double of middle two numbers and just add. 21 cube. 1, 2, 4, 8. Double of 4 is 8, double of 2 is 4. Just add. 1, 6, 12. So 1 goes carry over. 9, 2, 6, 1. Very simple. We start in the backward order. Let's do once again. 21 cube. So we write 1, a square, a cube. Double of middle numbers. 8 and 4. And add 1, 6, 2, 9, 2, 6. Let's try for 31 cube. 1, a is 3, 9, 27. Double of these two numbers, 6. So 1, 9, 7, 2. 2, 9, 7, 9, 1. 1a, a square, a cube. Double of these two, we write there and just add them. Let's try for 41 cube. A is 4, 1, 4, 16, 64. Double of 16 is 32, double of 4 is 8. Just add. 1, 2, 12. 1 carry over. So 48, 1, 49, 4 carry over. It's 6, 8, 9, 2, 1. 6, 8, 9, 2, 1. Let's try for 51 cube. We try for 51 cube, where a is 5. We write in the reverse order. So we had 51 cube. It's 1, 5, 25, 125. Just double of middle two terms, 50 and 10. So it's 1, 15, 5, 1 goes carry over. 50, 25, 75 plus 1, 76, 7. 125 plus 7 is 132. So it's 132, 65. That's a cube of 50. Yes? So when it's start with 1, we write 1a, a square, a cube. When it's end with 1, we write in the reverse order. 1a, a square, a cube. And in both the cases, we do the double of the middle term. Just write double of the middle term below them and add to get the cube of a number. Either starting with 1 or ending with 1. Yes? Now, let's try to find cube of a number having the same digits. So what we do? We write a cube, a cube, a cube, a cube. Then double of middle two terms and then just add. It's a cube. That is, both digits are same. So 8, 8, 8, 8. Double is 16, 16. Just add. 8, 16 plus 8 is 24. 2 carry over. 16 plus 8, 24. Plus 2, 26. 2 carry over. 10648. Cube of 20. We write a cube. Let's try for 33 cube. A is 3. So a cube is 27. 27, 27, 27. Double of middle 2 is 54, 54. Just add 7, 2 carry over. 54 plus 27, 50, 70, it's 81, 3, 83, 8 carry over. It's 81 plus 8 is 89, 8 carry over. 27 plus 8 is 35, 35937 is cube of 33. So we write a cube, a cube, a cube, a cube. Then double of middle two terms and just add the values. Let's try for 44 cube. A is 4. So 64, 64, 64, 64. Double of middle two terms. 128, 128. Just add. We write single digit. 4, 6 carry over. So 128 plus 64 plus 6. 120 plus 60 is 180. 8 plus 192 plus 6 is 198. Once again, 120 plus 60 is 120 plus 60 is 180. Plus 8 is 188. Plus 4 is 192. plus 6 is 198. 8, 19 carry over. 120, 120, 60, 180, 192. 192 plus 19. 192 plus 9 is 201 plus 10 is 211. So 211. 21 is the carrier. So it's 85. 8518. 44 cube is 8518. Yes. 64, 64, 64, 64. Double 128, 128. Now 64, 4, 6 carry over. 64 plus 128 is 192. Plus 6 is 198. 19 carry over. 192 plus 19 we have to done. 192 plus 20 would have been done. So it becomes 212. Minus 1, 211. 121 carry over. So 21 plus 64 becomes 85. Yes. Now let's try for 55 cube. A is 5. So we can say 125, 125, 125, 125. Just double of middle two terms, 250. Add 5, 12 carry over. This is 250, 125 is 375, 377, 387, 738 carry over. Now what 250 plus 125 is 375. 375 plus 8. 375 plus 8 is 383. Plus 30. Plus 30 is 383 plus 30 is 313. 383. Once again 250 plus 125 is 375. Plus 30 is 405. Plus 8 is 413. 3 and 41 carry over. Now what we had, 125 plus 41 is 166. So 166375 is the answer. 166375. Once again let's try. 55 cube, 125, 125, 125, 125, that is A cube. Double 250, 250. 5, 12 carry over. 375 plus 12 is 387, 38 carry over. 250 plus 125 is 375, plus 30 is 405, plus 8 is 413, 341 carry over. 125 plus 41 is 166, so 166, 375 as the answer. Yes? Now cube of a number having different digits. So what we use in this part? It says we write A cube. Suppose we have to find AB cube. So A cube, B cube, we write A square B, AB square. Then double of the middle two numbers, 2A square B, 2AB square, and we simply add what we had done in the previous part. Let's see 23 ka cube. We try for 23 cube. 2 cube is 8, 3 cube is 27, A square, 4 into 3 is 12, AB square, 9 into 2 is 18. A is 2, B is 3. A cube is 8, 3 cube is 27. A square, 4 into 3, 12. AB square, 2 into 9, 18. Then double, 24, 36. Add 7, 2. 18 plus 2, 20 plus 36, 56, 5. 24 plus 12, 36 plus 5, 41. 1, 4, 8, 4, 12. 1, 2, 1, 6, 23. Let's try in this part. A is 3, B is 4. A cube is 27, B cube is 64. A square 9, 9 into 4 is 36. B square 16, 16 into 3 is 48. Now double of 36, 72, double of 48, 96. Just add 4, 6 carry. 96 plus 6 is 102 plus 8, 110 plus 40, 150, 0, 15 carry. 70, 30, 100, 110, 6 and 2, 8, 5, 13, 123, 3 and 12 carry over. This is 39, 39304. Once again, A cube, 27, b cube 64. A square 9 into 4 36. AB square 16 into 3 48. Double of 36 72. Double of 48 96. Just add 4. 6 goes carry over. 96 plus 6 is 102 plus 48 150 0 15 carry over. 70 30 100 110 6 5 11 12 2 13. So 123 3 and 12 carry over. 27 plus 12 is 39. Let's try for 42 cube. 4 cube 64, 2 cube 8, 4 square 16 into 2 32, 2 square 4 into 4 16. This is a square b, this is ab square. Just double 64 32, add, it's 8. 16 plus 32 48, 4 carry over. 60 30 90, and this is 10 100 0 and 10 carry over. 74088. 74088 is 42 cube. It's 42 cube. We are finding cube of 42. So what formula we are using? A cube. We are using a cube, a square b, ab square, b cube, and we are writing double of this, 2a square b, 2ab square. We simply adding this one. Yes? Clear? So let's move to next segment, that's division of numbers. How do we divide these numbers? So what we do, we take denominator as 100%. So just solving the first, 100% is 53, 10% is 5.3, 1% is 0.53, and so on. By using these percentages, we add them, try to make numerator. This process is called division. We used to find value of 12 upon 53. We know 10% is 5.3. So 20% is 10.6. This is more than 10.6. 2% is 1.06. So 22% is 11.66. We got 22%. Now we have to move to closer to this. 1% is 0.53. So if we add 1%, it goes above 12. So my answer lies between 22% to 23%. If 10% is 5.3, 1% is 0.53. 1% we are talking about, 1% is 0.53. Can I say 0.5% is half of this, 0.265. So we add 0.5% to this. So we get 0.265. 5, 12, 6, 7, 8, 9, 11.925. So this is slightly more than 22.5%. If we are talking decimal, slightly more than 0.225. So we can figure out the options also. If we slightly add 0.01, 0.1 percentage, we can get the value. Because 1% is 0.53, so 0.1% is 0.053. So this is 8, this is 5 and 2, 7, 9, 11.978. We goes much closer, 22.6. So more closer to 0.226, slightly higher than this. Let's try for 131 upon 742. Can we gauge? We know this number is less than 20%. How can we say this? So 10% is 74.2. So 20% is 70 double is 140, 148.4. This is less than 20% for sure. This is less than 20%. Now 131, if we subtract from this, so how much we need to subtract? 17.4 we need to subtract. So 1% is 7.42, 2% is 14, so we have to subtract more than 2 but less than 3. So answer lies somewhere between 17 to 18%. Now let's try to figure out this. What is 20% we have calculated? 148.4. So if we subtract 2% from this, that is 14.84, we are left with 18%. So this is 6, 5, 3, 133.56. We have to subtract 2.56 more. This is 18%. So answer lies between 17 to 18%. Subtract 0.5% and see which option is closer. In decimal part, my answer is somewhere between 0.17 and 0.18. If options are given, we can easily zero down to the options. Yes. Let's try more numbers. 127 upon 532. So we need to find the value of this. Can you say 10% is 53.2. So 20% is 106.4. Just double of this number. So 2% is 10.64. So we had 22% as 4, 10, 7, 117.04. We required more than this. We required more than this one. It's 4, 10, 7, 117. Around 10 we require, but slightly less than 10. So answer is more than 23% but less than 24% for sure. So if we add 1%, that is 5.32. We know this is less. 23% is 6, 3, 12, 122.36. If we add 1% more, it goes beyond. So my answer somewhere lies between 23 and 24%. This is less than 23 and 24%. If we keep on adding the values, 23% we got. So we can add 0.5, 0.2, 0.3 we can add. So we get this answer as exactly equal to 23.87%. So less than 24 but more than 23. So in decimal it's 0.2387. So we are calculating surely up to 2 places of decimals, and then we can see the options whether we require more or not. We can find this value exactly. Suppose 23% is 122.36. Now what is 1% we have? 1% we have as 5.32. What is 0.2% we have? 2% is 10.64, so 0.2% is 1.064. Just subtract, we get 0.8%. If somehow we need to find exact, we are supposed to subtract this part. So it's 6, 5, 2, 4.256. That means if I add 0.8, this becomes 4.256. 6, 11, 6, 6, 126.66. Very close to this. So answer is somewhere close to 23.8%. In decimal we had that is 23.8%. In decimal we will write this as 0.238 and between 0.239, somewhere between that. Yes? Now, let's try this number. 432 upon 947. We need to find the closest range for this. What is 50%? That is half of denominator. Half of 900 is 450. 40 is 20. So 470. 7 is 3.5. 7 is 3.5. So we can say, sir, we can directly find 50%. So 450, 40 half is 20, 470, 473.5. This is 50%. Now numerator is less than this. So answer is less than 50%. If we subtract 5%, that is 47.35. If we subtract, so we get 45%. and this is, if we subtract 0.15, 7 and 13, 6, 4, 26.15. So we require to add some value. So 26 to 32, we required 6 more. 1% is 9.47. So answer is between 45 to 46%, and we required around 2/3 of this value, that is 1%, 9.47. We required around 6. So if we solve it exactly, it comes out to be 45.6% closer. If you wish to find, we can do this also. 45% is 426.15. What is 0.5%? 4.735. And what this adds up to 45.5%. This is 5, 8, 8, 10, 430.885. We required slightly 1.2 more to make 432. So what is 0.1%? 10% is 94, 1% is 9.47, 0.1% is 0.947. So 45.6% is 7, 5, 12, 8, 4, 12, 13, 18, 4, 31.832. Very close to this. So in decimal it's 0.456. So without actually dividing, I'm just writing this part. We can do this part mentally. We just write the value 10%, 20% or 50% less 5%, and straight away zero down to the options. Or we can exactly found up to 3 places or 4 places of decimals accurately. Yes? Now let's try other numbers. 2345 upon 8453. This is 2345 upon 8453. Now let's try to find 25%, 1/4 of the numbers totally. 8400 half is 4200, 4200 half is 2100. So 1/4 is 2100, 52 half is 26, half is 30. So can you say this is 2113.52, then 1/4, 0.25 we can say. Approximately we zero down to 8400 half is 4200, 42 half is 2100. This is 53. 52 half is 26, 26 half is 13. And 1/4 is 0.25. Is this part clear? Now we need to find 2345. This is less. So answer has to be more than this. Now we just add 2.5. This is 25%. So we add 2.5% to this. So this becomes 27.5%. 211.325. We just shift decimal by 1 place. So this is 5, 7, 5, 4, 2, 3, 2324.575. This is 24. This is 21, 45. So we required 21 more. We required 21 more. 2.5% is 211. So just add 0.25% to this. So it becomes 27.75. 2.5% is 211. So 0.25% is 21.1325. 5, 7, 10, 7, 5, 4, 3, 2, 3, 4, 5.70. So slightly more than this. So actual answer value is 27.74. We had got 27.75, slightly more than this. So in decimal we write this as 0.2774. So we are just doing approximation at the 4th place of the decimal. So in decimal it's 0.2774. Percentage is somewhere slightly less than 27.75%. It's actually 27.7416%. Yes. Let's try this part. 1234 upon 9475. We have to find the value of this number. 10% is 947.5. What is 1%? 94.75. We have to come closer to this. What is 3%? 90 into 3 is 270. 4 into 3 is 12. 282. 0.75 into 3 is 2.25. So it's 284.25. So we add 3% to this. 284.25. So it's 0.75, 1, 3, 1, 2, 3, 1. So slightly more than 13%. Slightly more than 13%. So we got 1231.75. Approximately 2.25 more is required. 10% 947, 1% 94, 0.1% is 9. Very less value is required. So very approximately equal to slightly more than 13%. We write this as 0.1. Yes, its actual value is 13.0237%. Yes. Now, suppose if numerator is bigger and denominator is smaller, we write this as 15 into 2 plus 2 by 15. So we take denominator as 100%, it's twice the denominator, so this is 200%. Now let's write 2 by 15 by the same method. 10% is 1.5, 1% is 0.15, so 3% is 0.45. So 13% is 1.95, which is very closer to 2. So this is 13% plus something. So answer is 213% plus some value. In decimal we write this as 2.13. Yes. Denominator, it's twice the denominator, so 200% plus 2 by 15. Then 2345 upon 2013, we can write this as 2013 upon 2013 plus 332 upon 2013. This is 100% plus 10% is 201. So somewhere around it should be 15-16%. 10% is 201.3. 5% is half of this. 100.65. So 15% is 5910. 301.95. This is more than 15%. And what is 1%? If we add 1% is 20.13. 20.13. So 16% is 8, 10, 2, 322.08. It's slightly more than 16% plus 100%. So we can say it's 100% plus 16%. So 116% plus something. A fraction value which is less than 1%. Because 322 and we required 330, 10 more. 1% is 10. So half is 0.5% is 10.65, slightly less than 0.5%. So this value actually comes out to be 116.49%. Very close to 116.5%. If we wish to write this in decimal, we write this as 1.164. Yes? Clear? Now, percentage to fractions. How do we convert percentage to fractions? So, we can write this as 41.66 as 25 plus 16.66. 25% is 1/4 and 16.6 is 1/6. So, this is 3 by 12 plus 2 by 12, which is 5 by 12. We can also say, sir, 1 by 12, we can find the value of 1 by 12 as is 8.33%. So 5 by 12 is 8 into 5 is 5 into 8 is 40. 1.5, 0.15. So it's 41.65 approximately. So either we remember the fractions or we break this into known percentage whose fraction we remembered. 25 plus 16.66. 1 by 4 plus 1 by 6. So make denominator same. 3 by 12 plus 2 by 12. It's 5 by 12. Let's try for 50.33 wala part. We can say this as 20 plus 33.33 percentage. 20 percentage, we know 20 percentage is 1 by 5 and 33.33 percent is 1 by 3. So 20% is 1 by 5 plus 1 by 3, that is 5 and 3, 8. 8 by 15. This part we can convert. 15.78. 1 by 19 is 5.26. 3 by 19. 5 into 3 is 15. 20 into 3 is 60. 6 into 3 is 18. So 0.7. This fraction is 3 by 19. Yes? Fraction should be remembered. Now 31.25. 1 by 16 is 6.25. So 5 by 16. 5 into 6, 30. 0.25 into 5 is 1.25. It's 31.25 percentage. So you can straight away say this is 5 by 16. Yes? 58.56 percentage. So we can say this is 30% plus 28.56. This is 30 plus 2 into 14.28. 30% is 3 by 10. 14.28 percentage is 1 by 7. So it's 3 by 10. Fractional equivalent we are finding 2 by 7. So 21 plus 20, that is 41 upon 70. So this value of in fraction, this is 41 upon 70. When we remove the percentage sign, we get 100 in the denominator. So it's 41 by 70. Fractional. Fraction. How do you write in fractions? A upon B form. Now this 52.22 is 30 plus 22.22. 30% is 3 by 10. Now 1 by 9 is 11.11 percentage. So 2 by 9 is 22.22 percentage. So 27 plus 20 is 47. 9 to 10 is 90. 47 upon 90. When we break in this part, it will be a great help when we are solving data interpretation. So it's 47 by 90 part. Yes? $45.45. 1 by 11 is 9.09. So 5 by 11 is 45.45. So this fractional, this value is equivalent to 5 by 11. Now suppose we need to find the value of 47.77 percentage. 47.77 percentage is 77.77 percentage minus 30 percentage. Now 1 by 9 is 11.11. So this is 7 by 9 minus 3 by 10. So this is 70 minus 27. 70 minus 27 upon 90, which is 43 by 90. 43 by 90. Yes? Then we had 32.22%. So we can write this as 10 plus 22.22%. 10% is 1 by 10 and 1 by 9 is 11.11. So 2 by 9 is 22.2. This is 9, this is 20. That is 29 upon 90. So 32.22% is 29 upon 90. That is when you remove this percentage sign, you will get 100. This value is approximately equal to 29 by 90. Yes? Now, comparison of fractions, next segment. So, type 1, whenever numerators are same, the fraction with the least denominator is the greatest and the fraction with the greatest denominator is the least. We can say 3 upon 13, numerator is same across all the 4 which we are comparing. So we can say it's 3 upon 13 is the least. Then we had 3 by 8. Then we had 3 by 7 and 3 by 5 is the greatest. So when numerator is same, we just see the denominator. The fraction which has the greatest denominator is the least and the least denominator is the greatest. This is the ascending order. When denominators are same, the fraction with the greatest value is the greatest and the fraction with the least value is the least. So we wish to arrange them in ascending order. So it's 4 by 5. Then we had 7 by 5. Then we had 9 by 5. Then 11 by 5. Let's try this one. It's 19 by 16, 24 by 11, 17 by 13, 21 by 24, 23 by 15. If somehow somebody asks what is the greatest number among these, then it's straight away we can say this fraction has the greatest numerator as well as the smallest denominator. So this is by default the greatest among all the 5 fractions given, 5 values written. Now suppose we wish to arrange them in ascending order. So this is the greatest by default. So 24 by 11. Let's see. 19 by 16 is 1 plus 3 by 16. 24 by 11 is 22 plus 2 by 11. 17 by 13 is 1 plus 4 by 13. 21 by 14 is 3 by 2. 1 plus 1 by 2. And 23 by 15. 23 by 15 we talked about. This is 1 plus 8 by 15. Now we have to just either we find the values of them in percentage and then we can compare, as this value is exactly 1.5. This is more than 2. All others are less than 2. And then we arrange them in ascending order. First part is. So 3 by 16. 1 by 16 is, we can find the value of 1 by 16 and then multiply by 3 by 16. So we get the value in percentage. One method is this. This is 3 by 16 is 18.75. So 1 plus 1 by 16 is We can find the value 1 by 16. 1 by 16 is 6.25. So 3 by 16 is 18.75% more than 1. 1 by 11, this is the greatest amount. 1 by 13 is 7.69. 1 by 13 is 7.69. So this is 4, somewhere around 28, 29 somewhere, percentage 30 point some percentage. So 4 into 7.69. That is 30 point some percentage. This is 50 percentage. And 1 by 15 is 6.6. This is more than 50% because 7.5 upon 15 plus 0.5 upon 15. So straight away we can say 24 by 11 is the greatest. Then we add this 23 by 15. This is more than 1.5. Then we had exact value 1.5, which is 21 upon 14. So we had arranged these fractions. Now 19 upon 16 and 17 upon 13. This is more than this. So we say 17 upon 13. And then we had 19 upon 16. So we had the ascending order also. We can compare how much more they are with plus 1 or plus 2. Or we can simply find the percentage part also. So in this way we can compare them. Had the question been given, who is the greatest among these values? So we straight away says this has the highest numerator as well as the smallest denominator. Yes? This was type 3. Now let's try type 4. We can say 64 upon 328. It is 32 upon 164, which is 16 upon 82. 16 into 5 is 80, which is 8 upon 41. 16 into 5 is 80, 8 into 5 is 16 into 5 is 80, 8 into 5 is 40. This is approximately equal to 1 by 5. 28 upon 152 is 14 upon 76, or we can say 7 upon 38. This value is approximately equal to 1 upon 5.5. So out of these, numerators are same. So 64 upon 328 is bigger than 28 upon 152. We can say this is 18 upon 88, or 9 upon 44. This is also approximately equal to 1 upon 5. This is 7 upon 28, that is 1 by 4. Now out of these, this is the greatest value we had, 49 upon 196. And this 28 upon 152 is the least value. Now if we need to check out of these two values, so we have to find the value out of these values, which will be the, we have to check these two values. So we have to see whether 64 upon 328 is bigger or 36 upon 176 is bigger. Approximately they are equal to 24, 1 by 5. So 10% is 32.8, 20% is 64, 65.6, 1% is 3.28. This is somewhere around 19, lower than 20%. 10% is 17.6, 20% is 35.2. This is bigger than 20%. So no need to calculate further. You can say 36 upon 176 is bigger than 64 upon 328. So this is the ascending order we have. 28 upon 152, 64 upon 328, 36 upon 176, 49 upon 196. Yes, this was type 4 we have. Type 5. Now if a fraction is less than 1, all the fractions are less than 1, and you find there is a constant difference between denominator and numerator, which is 6 in this case. We are finding a constant difference, that is 6. This difference is constant and the fraction is less than 1. Then the fraction with larger value in the numerator upon denominator is the largest. If all the fractions are less than 1 and you are finding a common constant difference, 6 in this case, the fraction with the largest value is the greatest. So 35, we can straight away write 35 upon 41 is the greatest among them. Then we add 31 upon 37. Then we have 23 upon 29. Then we had 17 upon 23. And the least one is the one with the smallest value. So if a fraction is less than 1 and you are finding a constant difference, the denominator minus numerator is constant, that is k in all the cases. Denominator minus numerator is constant in all the cases, same value. Then the fraction with the greatest value is the greatest and the fraction with the least value is the least. So 35 upon 41, 31 upon 37, 23 upon 29, 17 upon 23, 13 upon 19. This value remains, this is an ascending order. But if is the other way around, this was the type 5, then we add in type 6. If the fraction is greater than 1 and you are finding still a difference is constant, which is 4 in this case, it's a constant difference you are observing. 4 is the difference, constant. K is 4. Then the fraction with the smaller values in the numerator and denominator, smaller values in the numerator and the denominator is the greatest. Is greatest. This is for this type. If the fraction is greater than 1. So can we say in this case, if we talked about the fraction is greater than 1, then the fraction with smaller values in the numerator and denominator is the greatest. Yes. So how do we write this? 27 upon 23 is the greatest. Then we have 29 upon 25. 27 upon 23, 29 upon 25. Then we have less than this is 31 upon 27. Then we had 43 upon 39. And then we had 57 upon 53. So if the fraction is greater than 1, then the smaller values in the numerator and denominator will give us the greatest value overall. If the fraction is less than 1, then largest value in the numerator and largest value in the denominator gives us the greatest value, provided the difference among all the fraction is constant, that is k. Yes? Type 7. Arrange them in ascending order. So all these values are less than 1. Can you say this is 1 minus 2 by 70, 1 minus 6 by 29, 1 minus 3 by 34, 1 minus 4 by 50. That is 1 minus 1 upon 8.5, 1 minus 1 upon 4.7 approximately, 1 minus 1 upon 11.33, 1 minus 1 upon, it's 4 upon 15, so 3.75 you can say. These are 12, then 3075. Now, 1 is common in every part. No. The case in which we are subtracting 1 upon the greatest term, 1 upon greatest term, we are subtracting the least part, will be the greatest. So we can say 31 by 34 is the greatest. Then it's 15 by 17. 15 by 70. Then we have 23 by 29, lesser than this. And the least is the one whose denominator in the subtraction part is the minimum. We are subtracting the bigger value. So it's 11 by 15. So 11 by 15, 23 by 29, 15 by 17 and 31 by 30. Yes? Clear? We had one more method to solve these values, one more way to solve these values. 1 by 15 is 6.66 in percentage. 10 by 15 is 66.66. If we add this, so 11 by 15 is, it's 12, 3, 73.32 percentage, around 73.33 percentage. This is 73.32 percentage. 1 by 29 we had 3.44. So we can say 3 by 29 is 9 and 1.2, 10.32 percentage. And 10 by 29 is 34.4. This is 10 by 29. So 20 by 29 is 68.8. And 3 by 29 is 10.32. So 2, 11, 9. 79.12. Approximately, this is 79.12. 1 by 17, you can also know 1 by 17. Know the fractions, we can calculate the 1 by 17 is 5.88. So 10 by 17 is 58.8. 5 by 17, we can add 29.4. We add these two values. 15 by 17 is 12. 8 for 12. 18. 88.2. This is around 88.2 percentage. Now 1 by 34. 1 by 34 is 2.94. We have to find 31 by 34. Can I say 10 by 34 is 29.4. So 30 by 34 is 60, 27, 87, 88.2. And 1 by 34 is 2.94. 1, 11, 8, 9, 10, 11, 91.14. So this value is around 91.14 percentage. So we know the straight values of, exact values of every part. It's 1 by 34 is 2.94. So 10 by 34, 29.4. 30 by 34, 60. 87, 88.2. 1 by is 2.94. 4, 11, 91.14. So percentage wise, which term is the greatest? 31 by 34 is the greatest term. Then what is the next term we had? 15 by 17, 88.2 percentage. 15 by 17 we had. Then we had 23 by 29, 79% around. And then we had 11 by 15 as the least part. Yes? Clear? Now there is one more way to compare the fractions. If a numerator is given as a upon b, if we increase the numerator by x% and denominator by y%, if x is greater than y, that is increase in the numerator is more than the denominator, then fraction will increase. For example, a fraction is a by b is given. I increase this fraction by 10% in the numerator as well as 10% in the denominator. So I increase it by 1 point, multiplied by 1.1. Fraction will not change. It will remain as a by b. But if I increase the numerator by 20% and increase the denominator by 10%, this value will be greater than original fraction because this value is more than 1. If you increase the numerator by 10% and denominator by 20%, then this value is less than a by b, as this value is less than 1. So in this manner also we can compare different fractions. Yes? Now let's move to the next segment. How do we add the numbers? So we'll be learning two methods in this. First, we are adding two digits at a time. So it's 78 plus 5 is 83 plus 70 is 153. We are adding two digits, unit first then tens. 78 plus 5 is 83 plus 70 is 153 plus 3 is 156 plus 10 is 166, 170, 190, 191, 261. So we write 61, we take 2 as carryover. First we add carryover part. 2 plus 1, 3, 23, 27, 57, 63, 103, 63, 103, 111, 181, 189, 279. Let's do it once more. We add from the right hand side. We are adding two digits. 71 plus 4, 75, 95, 98, 108, 113, 183, 191, 183 plus 8 is 191, 261, 61, 2 carryover. Adjust carryover first. 98 to 100, 108, 178, 184, 224, 228, 258, 259, 279. Yes? Let's try this number. We will be adding two digit. Unit first, then tens. 62, 67, 87, 88, 108, 110, 170, 171 and 90, 261. 171 and 90, 261. Carry over 2. Adjust 2 first. 14 to 16, 20, 50, 57, 87, 91, 101, 109, 129. Let's try from the left hand side, same method. We are adding two digits. 91, 93, 153, 154, 174, 179, 199, 201, 261, 61, 2 carryover. Adjust 2 first. 28 plus 2, 30, 34, 44, 51, 81, 85, 115, 119, 129. So what we are doing, we are adding two digits at a time, unit first, then followed by tens. So 27961 is the answer for the first part, 12961 was the second part. This was method 1 of addition. Let's learn another method. First we had 1000 digits. 1000 place, then 100 place, then 10, then 1. 2 plus 3 is 5, 4, 9, 7, 16, 9, 25. It's 25,000. Once again, 2,000 digit we are adding. 2 plus 3, 5, plus 4, 9, 7, 16, plus 9, 25,000. 100 digit, 1 plus 4, 5, plus 6, 11, plus 8, 19, plus 8, 27. This is 2700. Then 10 rupee wala part, 10 digit, 7, 7, 14, plus 1, 15, plus 2, 17. 17 plus 7 is 24. This is 240. Then unit place, 8, 5, 13, 3, 16, 4, 20, plus 1, 21. Just add this part, 1, 6, 9, 7, 2, 2, 7, 9, 6, 1. Let's try in this part. 1000 place first, 1, 3, 4, 3, 7, 1, 8, and 2, 10. So it's 10,000. 100 wala part, 4 and 4, 8. 8 and 7, 15. 15 and 4, 19. 19 and 8, 27. This is 2700. 10 digit, 6 plus 2, 8. Plus 2, 10. Plus 6, 16. Plus 9, 25. We had 25. Plus unit, 2 plus 5, 7. 7 plus 1, 8. 8 and 2, 10. Plus 1, 11. Just add this part. 1, 6, 9, 2, 1. 1, 2, 9, 6, 1. This is also one of the methods. How do we add the numbers? Yes? 1, 2, 9, 6, 1 as the answer. Now, how do we subtract the numbers? We subtract 2 digits at a time. So 28, we need to go from 28 to 48. We require 20 more. 31, we first make the unit part same. 31 plus 1 is 32. From 32 to 72, we required 40 more. So it's 41. Once again, see this part. 7248 and 3128. The unit place is same. So from 28 to 48, what should we add 28 to get 48? Sir, it's 20. Now 31 plus 1 is 32. From 32 to 72, we required 40 more. It's 41. Let's see the middle part. From 45, we cannot subtract. From 45, from 15, we cannot subtract 45. So we borrow 1. It's 115. So from 45 to 115, we required 70. Then this is 71. So 92 plus 9 is 101. Until 171, we required 70 more. So this is 79 because we borrowed 1 from this side. Once again, we cannot subtract 71 from 71, 92. So we borrowed 100. It's 171 because 1 we had given carry over. So 171 we subtract 92. 92 plus 9 is 101. And from 101 to 171 we required 70 more. So it's 79. Now this is 45 because we had given 1 borrow. We cannot subtract 78 from 45. So we borrow 1. It's 145. Now 78 plus 7. 78 plus 7 is 85. So from 85 to 145 we required 60 more. 78 plus 7 is 85 and 85 to 145 we required 60 more. So it's 67. Now it's 22. This is 11. 11 plus 1 is 12. 12 to 22 we required 10 more. This is 11. Once again, let's divide this, subtract this number once again. 2, 3, 4, 6, 7, 2, 1, 5, 11, 78. We take 2 digits at a time. 92, 45. Now from 15 we cannot subtract 45, so we borrow 1. So it becomes 115. So 45, 115, we required, what should we add 45 to make 115? Sir, it's 70. Now it's 71 here. Now from 71 we cannot subtract 92. So we take borrow. It's 171. In 92 we add 9. It becomes 101. And from 101 to 171 we required 70 more. So 9 we added initially. This is 79. We have taken a borrow from this side also. Now this is 45. From 45 we cannot subtract 78. So we again take a borrow. So it becomes 145. 78 plus 7 is 85. From 85 to 145 we required 60 more. It's 67. Yes. Then 1 is gone. It's 22. 11 we need to subtract. It's 11. 1167 7970. Let's try this part. First we try to make the unit same. From 18 we cannot subtract 93. We take a borrow. It's 118. 93 plus 5 is 98. From 98 to 118 we require 20 more. So it's 25. Now it's 61. We cannot subtract 72. So we borrow 1. 161. 72 plus 9 is 81. From 81 to 161 we require 80 more. So this is 89. It's for 61 we had taken borrow 161. So 72 plus 9 is 81. From 81 to 161 we required 80 more. It's 89. Now this is 72. This is 42. 42 plus 30 is 72. Straight away we can say it's 30. 81. It's 54. Now 54 plus 7 is 61. 61 to 81 is 20. So we can say 27 because 7 we added initially. 54 plus 7 is 61 and 20 is 81. 43 plus 9 is 52. 52 to 72, 20 more. It's 29. Yes. Let's try this once more. 72, 81, 73, 62, 18. 43, 54, 42, 72, 93. From 18 we cannot subtract 93. First we borrowed 100. So we take 2 digits at a time. So 118. 93 plus 5 is 98. 98 to 118 we require 20 more. So this is 25. Now we have taken one borrow. It's 61. Cannot subtract 72. So we borrowed 1. 161. 72 plus 9 is 81. From 81 to 161 we required 80 more. So it's 89. Now we had given one borrow. This is 72. 42 is less than this. We can subtract 42 plus 30 is 72. So it's 30. 54 is less than 81. 54 plus 7 is 61. Plus 20 is 81. So this is 27. 43 plus 9 is 52. From 52 to 72 we required 20 more. So it's 29. Yes? Clear? So we subtract, take 2 digits at a time. Now comparison of numbers. So all numbers base is greater than 1. Power is 1 by 2, 1 by 3, 1 by 4, 1 by 6, 1 by 12. You can write this as 2 to the power 6 by 12, 2 to the power 4 by 12, 4 to the power 3 by 12, 6 to the power 2 by 12, 12 to the power 1 by 12. So 2 to the power 6, 1 by 12, 2 to the power 4, 1 by 12, 4 to the power 3, 1 by 12, 6 to the power 2, 1 by 12, 12 to the power 1, 1 by 12. This is 64 to the power 1 by 2, 81 to the power 1 by 12, this is 1 by 12, 64 to the power 1 by 12, 81 to the power 1 by 12. Again 64 to the power 1 by 12. These two numbers are same. 36 to the power 1 by 12 and 12 to the power 1 by 12. So if we wish to arrange them in ascending order, smallest is 12 to the power 1 by 12. So the smallest part we have. Twelve to the power 1 by 12. Then we add 6 to the power 1 by 6. Then we add 2 to the power 1 by 2 and 4 to the power 1 by 4. Both are same. They both are equal. Then we add greatest as 3 to the power 1 by 2. Yes? We can straight away come to this step if we just raise power 12 to all the numbers as all are greater than 1. So we directly get 2 to the power 6, 3 to the power 4, 4 to the power 3, 6 to the power 2, 12 to the power 1. So this is 12, 36, 64, 81, 64. So we know this is the greatest and this is the least. So if we have to write in ascending order, it's 12 to the power 1 by 12, then 6 to the power 1 by 6, then 2 to the power 1 by 2 and 4 to the power 1 by 4 are same, and then we add 3 to the power 1 by 4. So is the ascending order we have. Yes? I hope this part clear to everyone in the class. Now, we should also be familiar with percentage and their fractional part, their fractional equivalent. You should be remembering these also. So, just to be do a calculation mentally also and accurately also. 1 by 1 is 100%, 1 by 2 is 50%, 1 by 3 is 33.33%, 1 by 4 is 25%, 1 by 5 is 20%, 1 by 6 16.66%, 1 by 7 14.28%, 1 by 8 12.50%, 1 by 9 11.11%, 1 by 10 is 10%, and 1 by 11 is 9.09%. Now suppose somebody asks me the value of 7 by 9, so I could straight away say 77.77%. 6 by 9 is 66.66%, 5 by 9 55.55%, 1 by 11 is 9.09, so 3 by 11 is 27.27, 5 by 11 is 45.45%. We can straight away find. 1 by 7 is 14.28, 2 by 7 is 28.56. We can found in this panels. So 1 by 11 is 9.09. We should learn the fraction. One by 12 is 8.33 percentage. 1 by 13 7.69. 1 by 14 7.14. 1 by 15 6.66 percentage. 1 by 16 6.25 percentage. 1 by 17 5.88. 1 by 18 5.55 percentage. 1 by 19 is 5.26 percentage. 5.26. 1 by 20 is 5%. 1 by 21 4.76. 1 by 22, 4.54. 1 by 23 is 4.34 percentage. 1 by 24 is 4.16. 1 by 25 is 4%. If we remember the fractions, we can many times in the mathematics questions use 7.69 percentage. So we know the total value has to be a multiple of 13. Or 6.25, we had used 18, 3 by 16 as 18.75. If 1 by 16 is 6.25, we can say 3 by 16 is 18.75. 1 by 19 is 5.26. So we can say 3 by 19 is 15.78 percentage. This value we had used during the initial part of the class. So 1 by 25 is 4%. This percentage and fraction has to be remembered. Now 1 by 26 is 3.84. 1 by 27 is 3.70. 1 by 28 is 3.57. 1 by 29 is 3.44. 1 by 30 is 3.33 and 1 by 31 is 3.22. Now this value 443322 can be remembered. 1 by 32 is approximately 3.12. 1 by 33 is 303, 3.03. 1 by 34 is 2.94 percentage. 1 by 35 is 2.85. 1 by 36 is 2.77. 1 by 37 is 2.70 in percentage. 1 by 38, 2.63. 1 by 39, 2.56. 1 by 40 is 2.5 percentage. Now what we are saying, if we know what is 1 by 27, 3.70, we can also say 1 by 37 is 2.70. This also we can reduce. You have to learn up to 20 or 30, whatever is convenient to you. But make sure you remember them and you know how to manipulate them. 1 by 31 is 3.22 percentage. So if somebody in question is asking 3.22 as a value percentage, that means total value is a multiple of 31 and this is one part out of that. Now writing few more fractions. 1 by 41 is 2.43. 1 by 42 is 2.38. 1 by 43 is 2.32. 1 by 44 is 2.27 and 1 by 45 is 2.22. So 1 by 46 is 2.17. 1 by 47 is 2.12. 1 by 48 is 2.08. 1 by 49 is 2.04. 1 by 50 is 2%. Now, if somehow we remember certain fractions and how do we convert them into one another. Suppose I know 1 by 34, so I can easily find what is 3 by 34. I just multiply. This also we have done in the initial part of the class. If I suppose 1 by 31 we know and we require to find 11 by 31. So what we do? We just add 10 by 31 plus 1 by 31 to get 11 by 31. This we have done in the initial part of the class. So fractions, if remembered, they will help you in your calculations as well as shorter your approach. And it's up to you how do you use. But somehow suppose you find in a profit loss discount question, it's a profit percentage is 5.26. We know 1 by 19 is 5.26. And he says 5.26 is the profit percentage. So we have to assume cost as a multiple of 19. So profit is one part, then selling price has to be a multiple of 20. This we can somehow try to use these fractions the way which we like. I hope this part clear to everybody, everyone in the class. Please learn the fractions, try to learn them up to 20 or 25, your convenient, and then slightly increase them. Sure. So please revise all those concepts which you learn in the class. Thanks to all. So thank you. Thanks.